that took us through training on Monday. Then we have members of the Students' Guild Council present. We have Terra Magica brands. And then I would like to also recognize Centenary Bank in their absentia. They contributed to this Innovation Week in a way, in another way, financially, but they are not able to be here. Thank you for that. We're going to have a short speech by our Vice President, Mr. Carlson Kalema, to also give us his few words of wisdom.
Good morning to you all. My name is Carlson Kalema Kasaga. I'm the Vice President for the Mbara University Engineering Society, and we are glad to have you here today. Let me hope you're all feeling comfortable. I think the difference is in the weather, but I mean, they say as a man, so for the men, I think you can quite try and bear with us as of today. I would love to welcome Soroti University. I would love to welcome Ernest Cook. I would love to honor our partners, CITT, Nile Breweries, Fundibots, and Innovation Village, SIBO, and Creative Campus. Today is going to be quite a busy day for each one of us. Let's all put on our fighting shoes and make sure we do our best. Yeah. Unfortunately, this morning, still a little bit up and down. I wouldn't say I have quite a lot to tell you as of now, but as the day goes on, I think we shall interact quite more. So anyways, on that, I don't know if it's okay for us to have a short word of prayer together. Is that fine? Okay, let us humble ourselves and pray. In the name of the Father, and of the Son, and of the Holy Spirit. Father Lord, we thank you for this day. We thank you for the gift of life. We thank you, Lord, for your provision. We thank you for your protection, Father. We thank you for the journey mercies that you have provided to each one of us from where we have come from to this place. As this day goes on, O Lord, let your light so shine amongst each one of us, Father, that your name may be glorified in heaven for the good works that you have done in our lives. O Lord, we pray that you give us good health, you give us guidance, knowledge, wisdom, and understanding, and give us the strength to face all that comes our way. For the Lord is my shepherd, I shall not want. He makes me lie down in green pastures, leads me beside still waters, he restores my soul, leads me in the paths of righteousness for his name's sake. For even though I walk through the valley of the shadow of death, I will fear no evil, for you are with me. Your rod and your staff, they comfort me. You prepare a table before me in the presence of all my enemies. You anoint my head with oil, and my cup flows over. Surely your goodness and mercy shall follow me from the days of our lives, now and forever. Amen. In the name of the Father, the Son, and of the Holy Spirit. Amen. I think, well, as of today, let me hope we all have our projects ready, those that are having projects, those that are going to do the paper contest. Let me hope you're all ready for the pitching. You know, you all have to convince us at this point, actually not me. You have to convince the judges, the different judges that are available today. Here, we are a campus that literally focuses on sciences and technology, but this side of campus, we are a campus of engineering, and engineers are people that always look at problems within the community and always try to make a solution to counter those problems. So as each one of us present here today, I do hope and I do believe that there are very many problems in this country and the world at large. And let us not think so small of ourselves, because I do believe that we have the capabilities, we have the powers as individuals to stand in whatever capacity that we do believe ourselves to be in, to do that we can, and that is in our might, to create a change. Yes? And, well, as of today, I think I might come back and give you a little bit more words of wisdom. I wanted to simply welcome you as of now and try to make sure you all have a good time. So I think it would be best we have more of a lively session, yeah, where I think some questions will be asked to the people of the audience and we see how pragmatic and competent we all are. So I think allow me to hand the mic back to Madame Isabel. Thank you.
Thank you, Mr. Carlson, for that. The former speaker said we're supposed to interact as we are here. So is there anyone from the audience who can tell us what the theme of this week has been? Anyone? All of you have been participating in it, in the competition. Who can tell us the theme of the competition? Yes?
Good morning to you all. My name is Bridget from Cavalry University. The theme of this event is Building a Better World Through Engineering.
Thank you for that. So, building a better world through engineering. Is there someone who has something to say about that theme? It's such a wide theme. So, who has what? Yes, please.
Distinguished ladies and gentlemen, I am Mugumi Anthony from Soroti University, and according to our theme, A Better World Through Engineering, engineering is not only about building projects, falling in love with technology, but it's all about creating solutions that can bring impact to the lives of the individuals that we serve as engineers. And to my perspective, in all aspects that we are going through, maneuvering through, day in, day out, even as of now, as we are seated, we have cameras, we have mics, we have bulbs and everything. That is the power of engineering. The structures we are seated on, the phones we are using, the technology, how we are communicating, all that is engineering. So it's up to us to create better technology that aligns with the human values, not only falling in love with the technology. Thank you very much.
Thank you for that. Yes, please. This is a familiar face. So it must be from Bara University.
Ladies and gentlemen, good morning to you. The theme building a better world through engineering literally explains that as engineers, we don't only build things like the buildings, make the phones and all the technology, but we focus on how we can help people using the knowledge that we have, like how we can help a region have water through an irrigation system, or how we can help people who are in need, not just building. Yes.
Thank you. So we are trying to solve issues that people are dealing with. That is the basis of engineering. Yes, are those the only people who have something to say? People, let's speak up. No one has anything to say. Or I can pick at random. Because as we are here, we are all aware what has brought us here. What has brought us here is to innovate, to be engineers. Maybe we can have a few words from our leaders. The people who guided the students to come. I believe all the students came with their teachers. Could I have the one who came with Kabale University, one of their lecturers, to give us what he thinks about the theme? Kabale University?
Yes, very good morning to you all. My name is Ogwal Emmanuel from Kampala International University. Considering the theme of the event, building a better world through engineering, I would like to say that engineering is not only theoretical, but it is a discipline application of science, where we solve real-world problems within our community, within the society, or within the industry. That being said, I would like to give you an example. In the mid-1970s, where we were still using a technology which is called the coaxial cable for information transfer. The problem was that the coaxial had what we call bandwidth, which is very, very low. And at the time, the engineers saw that that was not going to be sustainable for a long time. So in the future, which this is the future which they saw back then, you can see how population has increased over the years. Currently, I have observed even the nursery kids, these days are owning mobile phones, are having tablets. So all this is generating a lot of data traffic, which the coaxials cannot be able to transfer such huge amount of information. Now back then, a lot of money was invested in research in what we call the optical fiber. Now the optical fiber had so many advantages that it could offer to solve that problem of limited bandwidth. So in that, the bandwidth for optical fiber communication is actually very large. So meaning that it can accommodate so many people. And to date, you can actually see optical fiber being used widely to solve that problem that was realized back then. So to sum it up, in engineering, we do not only build any solution, but we build what we call sustainable solutions, solutions that are able to last over a very long period of time. And today, as a judge, we shall be looking at those solutions that you have come up with that should be able to solve real world problems within the community, society, and industries. However simple the solution is, it can rank highly if it is solving a real world problem. So we shall not be looking at very complex and flashy ideas that remain theoretical. We want those ideas to come to life. Thank you so much.
Thank you, sir, for that. From KIU? Yes? Thank you. So now allow me to invite our Dean, Mr. Dennis Bosa, to give us his welcoming remarks so that we can officially start this event.
Thank you so much. Good morning, everyone. Ladies and gentlemen, our invited guests, colleagues from our sister universities, our industrial partners, and most importantly, our brilliant students here today. I want to start with a brief question to everyone. How many of you have ever had an idea and it is still in your mind? By just a show of hand. Are we frank to ourselves? It seems we are not thinking. So most of us have had ideas in our mind, but we have never brought that idea into real life. And yes, exactly that is the problem we are here to solve. Because in engineering and in life, an idea that stays in your head is just an imagination. But an idea you build and it becomes a prototype or a service, it becomes an innovation. First of all, I would like to welcome all of you to this MUES Annual Innovation Week of 2026 at the Faculty of Applied Sciences and Technology, Bara University of Science and Technology. As the Dean of the Faculty, I'm honored and humbled to host our colleagues from other universities, Soroti University, Kampala International University, Ndeje University, Kadogo Community Polytechnic, Ernest Cook University, Busitema University, Kabale University, Makerere University, Kyambogo University, Uganda Matters University, and of course our own from Bara University. You are most welcome. Now, when engineers from all universities gather in such a place, we expect two things. One, great ideas. And second, very serious arguments about whose design is the best. And this is exactly what we want. Why does this week matter? You see, engineering students are very interesting creatures or specimens. Because engineers, when they see a problem, they don't complain compared to other people. But an engineer, when he sees a problem, the quickest answer they will tell you, oh, give me a minute, let me think about a solution. So sometimes even before understanding the problem fully, for them they are already thinking about the solution. And indeed, that's what defines an engineer. The curiosity, the boldness, and the drive to innovation. Let me give you a simple example here. In many parts of Uganda, for us who grew up from villages, you realize that when you are storing your maize infested with different organs, we have seen our mothers or young kids dying in hospitals because of lack of electricity. There was a power blackout somehow, somewhere. Also, we have seen that in our communities there is still a challenge of affordable construction materials. Now, an ordinary person may say, government etuyambe. Not so. But as an engineer, you would ask yourself, what can I do to solve this post-harvest problem? What can I do to create a hybrid system that can power a rural health center? Or what can I do to address the challenge of plastic pollution happening within our communities? And this is exactly the kind of thinking we expect from you this week. And I'm happy that we are at the climax of the Innovation Week. On the Innovation Challenge, and I heard it is about the Inter-University Innovation Challenge. This is not just a competition, but it is about turning theory into prototypes, turning prototypes into solutions, and hopefully we can turn these solutions into businesses. Because as engineers, in most cases, or as students, we have a tendency of, after all, I've produced a prototype, I've graduated, let me look for a job. Yet the prototype you have produced can make you a millionaire and a billionaire. So, if your innovation cannot, yet so many people are unknown, we are very happy you are here, and I want to challenge you. As you move around seeing the innovations being done by students, please do not ask, does it work? Instead, you can ask, can we invest in this? Can we scale this up? Because among these students, there could be a person who will solve your company's biggest problem. And instead of wasting resources advertising, calling for consultants, we have consultants here in this room. And these consultants will be guided by most of the staff we have in the faculty have worked in industry. So they lecture students from an industrial perspective. And also, moving forward with our industrial partners, we'll be reaching out to you. In Proc On, you will get an industrial supervisor. To the students, this is your moment. Use this week to test your ideas, fail and improve. This is part of human development. Network. Do not only take photos or create content. And most importantly, think beyond the marks or the grades or the judgment you'll get. Because in real life, no one will ask, what did you score? Instead, they will be asking, what can you do? So the projects you are coming up with, they are helping you in critical thinking, of which you thought of a problem, you kind of had different 5 alternative solutions, but why did you zero down to that? You should be able to defend your choice. As I conclude, let me leave you with this. The future of Uganda will not only be built by people who wait for solutions or who cry out for government yetuyambe, but it will be built by people who are in this room, who are willing to think differently, build boldly, and act in a courageous way. So let this week be a week of ideas, a week of collaboration, and a week where innovations meet impact. With those few remarks, I officially declare the MUES Innovation Week 2026 open. Thank you so much, and let the innovations begin.
Okay, thank you, Mr. Bosa, for that. So now we are going to proceed to the exhibition and judging ceremony. Allow me to recognize our chief guest of the day will be Honorable Elioda Tumwesije, who is the former Minister of Science, Technology and Innovation. He will be joining us a bit later. So I'm going to communicate how the judging is going to be distributed, the different rooms you're going to use. So for the paper contest, we're going to have the people participating and judging the paper contest to remain in this auditorium. Our judges are going to be Nasava Polycarp, Nuazira Octavius from Fundi Bots, Mrs. Asimwe Lydia, and Mr. Mukama Martin, then Mr. Alex from Terra Magica Brands. Those are going to be remaining in the auditorium with Madame Justine. She's going to be the one remaining with you. Then for the exhibition, you're going to proceed to first floor. You can use this back door, the door up, or you can use here. There are going to be people to direct you, those who are not aware of the rooms that you're going to be using. We're going to have Mr. Onenkan Ronald Shaban as a judge, Mr. Ogwal Emmanuel, Mr. Byamukama Dennis. Then you can be following Mr. Esego to show you where to go. Then we'll have Mr. Dennis from CITT as one of our judges. Then Dr. Anne Moore Oguti, and then Dr. Bashir Voji. Those will be the judges for the exhibitions, the project. So you can proceed to your respective rooms.
The participants, please come over to these front seats. Our innovators in thought, our innovators in research, our innovators in paperwork. Please come in front. I'll take the front seat. We are moving to the core of this session, and we will invite our first participant from Kabale University, Mr. Paradise Mwebembezi. Please come forward. Some round of applause for him as he comes over.
Thank you so much, the MC of the day, our dear judges, the organizers of this, and our fellow participants. Good morning. My name is Paradise Mwebembezi, a student of Kabale University. I pursue a bachelor's degree in civil engineering. I'm currently in year 4, and we are presenting a paper contest. I'm with my colleague who I'm going to allow to also introduce himself as we wait for the man who collected the slides to share them as we present using them.
Yes, good morning everyone. I am Jimuku Joshua, student of Kabale University, pursuing a bachelor's of civil engineering. Thank you so much.
For the contestants, when you're coming over, you come with your PC, you connect to the projector for your slides, and then you control. Yes, it will be much easier that way.
Given a form for the judges. So before you speak, you present your form to the judges. There are 6 judges. So you have the same number of papers. So you write your title for your paper, you present them to the judges, then you come and speak. That's that. And then to the participants, the time you're going to be given is maximum time is 10 minutes. So please do not exceed 10 minutes. Thank you.
We are officially going to start this session. I would like to I take this honor to invite our judges to come over and introduce themselves so that our contestants and us, we can know who is judging today. Thank you so much.
Thank you so much. My name is Mrs. Asimwe Lydia. I work here at MUST. I manage the MUST UCOBS project, which facilitates scholarships for PhD scholars that is affiliated to the Belgium institutions. But I also served for over 5 years here at MUST in a science, innovation, technology space with Comtech before I crossed over to this other project. My professional background is in management, where I focus on engaging teams, multidisciplinary teams, and looking at the dynamics of how teams work in order to build projects and grow organizations. So thank you so much for having me as today's judge. Over to you.
Good morning, everyone. How are we doing? My name is Martin Mukama. I work here at Mbarara University under the Center for Innovations and Technology Transfer. I serve there as the Senior Prototyping and Technology Development Officer. I have been in this space for 12 years now. Okay, so feel free to come and consult at the center anytime. I'll be happy to support you. I've worked on interventions that are currently being used in industry. Thank you.
Yes, good morning. Yes, my name is Octavius Nuwazirwe. I work with Fundi Robotics Limited, also known as Fundibots, as a technical associate. Fundibots, briefly, is an NGO that is into STEM training for institutions of higher learning and also secondary schools. As a technical associate, I've had a privilege to be mentored by one Comtech as an innovator. I've been mentored by the Youth Startup Academy Uganda, and I'm now a mentor. I'm happy to be here today as your judge. Thank you.
Good morning, team. Yeah, I'll keep it brief. Polycarp Mulepu Masaba. Someone changed the name to Nasaba, so I'm also feeling like a Western. Thank you so much. I work with Fundi Robotics, also known as Fundibots. I'm also a technical associate. I'm happy to be one of the judges. Thank you so much.
Good morning to you. Alex Nwagab is my name. I work with Teramagic Brands. We are into food production, and I'm an operations associate. And I'm happy to be here, and I want to tell you we recently concluded a mechanical design competition for clay roaster, and one of the students from MUST was a participant called Ahereza Pritazio. I'm looking forward to seeing him here. We had someone from KU, Mr. Muganga John. I don't know if he's in the room. Thank you very much for turning up for this event.
A louder clap, please, for our judges. Let's have our first innovators in mind. From Kabale University, Mr. Paradise Mwebembezi. Guys, cheer them up.
Water. It also causes gastrointestinal issues such as nausea, diarrhea, especially in vulnerable populations that were mentioned, children, and then we we also went to the recommendation part, which I will ask my colleague to also take us on the recommendation or what can be the cost-effective solution to the above challenge.
Thank you so much. Now, after seeing all those challenges that are brought up by those metals in the water, heavy metals, we came up with a remedy that is a biosand filter. Now, this biosand filter of ours, we have incorporated it with charcoal. But this locally made charcoal, but when it is crushed between a size of 0.5 millimeters to 2. Now, this charcoal, as you see, many heavy metals exist as positively charged ions in water. This, now remember, our charcoal that we are incorporating in our biosand filter is negatively charged, will attract the positive charge, the positive ions from the what? From our heavy metals. Remember, when iron is dissolved in water, it becomes ferrous what? Metal. Remember, we are having 3 types of iron. That is ferric, the one which is the rust, then ferrous, then organic bound, which exists on the plants. Now, I told you because of the way charcoal is formed, it is negatively charged. Now, the negative charge will attract the positive charge from the metals. Then, in so doing, we shall attract off the metals. Now, this is a design of a biosand filter, like for a household. And you can see the layers. This is the way. Okay, let me take you through the setup. Now, what we design, the setup you see there, we can incorporate our biosand filter to a storage system. Let's assume it is a tank. Then, the water will flow from the tank to our what? Biosand filter. But what we've changed here in the filter is that we have incorporated it with charcoal. And remember, we also have Shumudek, the biological layer that will grow on top. It is a predator that is going to feed on the bacteria that we have from the what? In the water. Now, this system is very good. And the other thing, it is very cost effective. Now, this side, what you're seeing, the first formula is Darcy formula for biosand filters. Now, we use that equation and come up with the area for the filter. Now, if it is a square, we use the square root to come. That's why you are seeing the length and the width. Okay, they are all the same, 35. Then this is our, we derive this number 3. We derive that ratio from the standards of the biosand filter, where the area, the cross-section area of the pipe, that is releasing the effluent is approximately, or like we did it like cross-section area of the effluent, like the effluent pipe over the cross-section area of the filter bed. That is the ratio there. That is what we used, and we came up with that. So we came up with those designs for the layers, as you see. Then the advantages, the biosand filter effectively removes pathogens, contaminants, and heavy metals, significantly improving water quality. The filters are simple to install. As they utilize natural biological process, they are environmentally sustainable, and they can be adapted in different local conditions. They are cheap in that. Thank you so much.
Our project is so much environmentally friendly as it also addresses SDG 6 of safe drinking water. Thank you so much for listening to us.
Thank you so much. I can tell this was not a last-minute thinking. This was hard work. We'll let the judges control this session for questions and clarity.
Okay, thanks so much, guys, for the biosand filter incorporated with carbon. It's an interesting innovation. I liked the flow of the presentation. However, I have a few questions for you gentlemen. You talked about the methodology. However, I didn't see maybe how you analyze the data to come up with the levels of the heavy metals. You have the results, but you didn't talk about maybe which approach did you use, which method did you use to do the analysis, maybe which specific test. Then two, about the choice of the heavy metals. I noticed a list of a few metals, the heavy metals. Why did you specifically look out at those ones? Iron, lead, manganese, and left out others. Then lastly, about the advantages of our biosand filter. We are talking about the effectiveness in the removal of pathogens. And the only thing I saw was about charcoal. How does charcoal effectively remove pathogens from the drinking water?
Thank you so much, sir, for your questions. If I can answer the last one, this biosand filter is not only containing charcoal. In fact, charcoal was brought in for the metals, but it has coarse aggregates, it has sand, and we have that layer that is on top that acts as a predator that consumes the other pathogens that come along with water. So we just incorporated it with charcoal specifically to remove the metals. Charcoal specifically deals with the metals, but the pathogens will be dealt with the other usual things that exist in the literature already. Then on the methodology of arriving on the results, we chose these metals. It is just was like a sampling of metals, maybe because of constraints of costs as students, but all the metals would have been tested. But we sampled these which we assume they are diverse in mining, and they were detected. So this was like a sample of the minerals, but we know there are very many. Thank you so much.
I wanted to propose that you have a piece of paper and you write all our questions, then you quickly answer one by one. They won't be many, but it will save time. You're getting one? Okay, good. First of all, I wanted to appreciate you guys coming from a university. You're young, energetic, and you go into a local community and you identify a problem that is affecting local Ugandans. Thank you so much for that. Yes, I also thank you for making it wide enough to look at the other, minerals, so that we are not scaling to one thing, so we are informed about a wider scale of things. Thank you for that too. My concern would be that I didn't get the number of the population affected. Either I missed it or you didn't include it. It's important to know if it's affecting quite a number of people in that district, so that now we see it is major or not. So I didn't see that. Then I would have loved to see if children are affected as well. I would have thought that a medical person on your team, do you have one, would have investigated in the nearby health facilities to see if they are dealing with cases that are similar to what you have described. Are they dealing with the children affected by that or adults? Then we say, yes, especially health facilities near where the mining is taking place from and those further to back up, the problem. I also felt your literature review was not intensive enough, either because this is a PowerPoint and it summarizes. So I'm hoping there's a paper that has really done good literature review, looking at previous researchers who have done relevant work. We shall be looking at that. Then also, who is going to buy this device, this solution you were presenting? Someone has to pay for it, and it is not the man of Buhara, because these people are farmers. They don't have a lot of money. Who is going to be buying these things and installing them? If you could answer those questions. Over to you.
Thank you, Lydia. I think a couple of questions that Lydia has asked also had similar questions to her. Maybe just one last one is related to your intervention. When I look at it, where does the unclean water enter from? Because I see the storage tank is up, and from there you have drawn that illustration. It looks like the water should be coming from this other side. Is there a pump that pumps it that way? Or the illustration is a little bit misplaced? Because from the storage tank, I would assume maybe the water goes through your filter, and then there's an outlet on this other side. Yeah. The other challenge that I am anticipating with your intervention is the flow rate is still too low. Because you're doing 30 liters per hour or 50 liters per day, which I think is too low. For a family of 12 people, if I have to do any cooking and I need to filter now, I don't know how much time it will take me to get enough water for cooking. Okay, so you need to think about that.
Yeah, thank you so much. I love the idea. It's something that any person would see and know something wrong is happening. My concern will only fall in the area of methodology in your process of research. I'm so much, probably I missed to hear this. Did you people consider available systems, the systems that have, because I'm certain it's not the first time such a problem has been occurring. They've been mining iron ore from that place for a long time, and somebody might have thought in your way and invented a solution. By understanding the available systems, it will help you to know to what degree you can apply your solution in the presence of the existing systems. Okay? Yeah, thank you so much.
Thank you. This is a learning process for all of us. One, how did you determine your sample size? I know Buhara sub-county is one of the most populated sub-counties in the Kabale district. And if you're looking at the households you looked at, don't you think your sampling in one or another left a big side for the population? Then, if you look at your solution, if you can go back to the slide where there is an image of your solution, if I look at it, I can't understand exactly how it is flowing from one step to another. So you have to try and see, if I look at your solution, how I can easily understand that it is moving from one step to another. Then when you look at the sand filter, we have different sands these days that are available. So how are you going to come up with that specific sand that will not contaminate the water itself? If I'm to take up your solution, how affordable is it? My fellow judge talked about it. If you look at the people we have in Buhara sub-county, assuming this solution costs $200 US, it's an assumption. How many people can afford it? So let's look at affordability and scalability. If you have this innovation and it is kept in one household, at the end of the day, does it benefit the entire population? So let's look at that. And I believe this is a very good, thoughtful innovation. Just needs a few touch-ups here and there. Thank you very much.
Thank you so much, our judges and our guiders. One of the judges asked on the number of population and also specifically if there are children who have already suffered cases of the above. The population in Buhara, as one of the judges mentioned, it is a big population. But for us, we took a sample. We took 30 households. 30 households. They are the people that and we used the purposive sampling to make sure we go on areas that are near or that are affected by the iron ore. They are the people that we sampled. And then we use the control points as the other 30 from far areas to make sure we find out, is this iron ore the problem in water? Oh, there is another problem. As we used the areas that were near the site and areas that were far from site. For health cases in the health center, we haven't gone there, but for us, we tested the water ourselves. We used only the engineering knowledge. We haven't applied the medical knowledge to go with a health worker and find out whether there are challenges that have already resulted from this. Then, like who will pay and who will buy this sand filter? As we are talking on the advantages, this biosand filter is so cost effective compared to other things that might be used, and also the other things that we found in the literature that would also be used to solve the same problem, because it uses sand, as you saw, aggregates, and you know that area is also used for quarrying. There is also quarrying there. So this coarse aggregate is readily available. Sand is also available, but however, as someone asked, sand can also bring another issue if it is not treated. But the sand and the aggregates are first put in sodium hydroxide for treatment to make sure they don't also pose health issues. So it makes it so affordable if it just needs treatment of that. And for us, we used this one on scale. But if it is used on an extensive area, because it uses cheap, readily available materials, it will work surely. And these people can collect a lot of water, because even overnight, water can be flowing. Because for us, we are considering household. Even the families that are there, they use it for household work. That is majorly what they use it for. And then on the illustration, like how water comes, water is coming from the roof. For us, we considered the roofs, and as you saw in the sampling size, when water comes from the roof, to avoid expenses on water that you have not collected, we only treat water that is from the storage tank. Then after, when it comes from the storage tank, it goes to the biosand filter. Then from the biosand filter, we collect water directly from down, from the coarse aggregates, as it goes to the collection center, where they will be collecting it for use in the homes. The flow rate is still low just because of the sample that we used. In fact, we came with our prototype, but however much it is not so much needed in the paper, but we used it directly, and it is here with us. Even before we go, you shall see it. It was like a sample. We put it on scale, but if we put it on a large thing, or we put it on the ground, this thing can collect a lot of water. Then the presence of the system in the area, as I said, this system is so much, it is the best for those people in Buhara. As you know, most of them, they are households that are low income households. And these materials are readily available in Buhara. If you tell them to use other methods of treating this water, it will be expensive. But these ones, they even need little technical knowledge compared to other things. Because if you tell them of using chemicals, they might apply much because of low technical know-how. But this one, just a technical person just comes to arrange the layers, which is cost effective. Maybe my colleague can also add on the setup.
Yes, on this setup that you see, where you see blue, this part, this is the pipe. It is, we raised it some centimeters above this. This is the bottom of the system tank, okay, the storage tank, because we believe there is some sludge here. So we are going to collect, what you see here is what? Is the pipe. Now, the pressure in the tank, because when you store water in the tank, it will what? It will accumulate a lot of pressure. So we are taking advantage of that pressure. So the water will flow like that. It will flow in that direction where you see the blue. Then it will come inside. Because this is a cross section, it's like I have cut through. Yeah, that is a cross section. It is illustrating. Then what you see here above is a supertenant. That one will help us to develop the shumudeck, the biological layer. That is the predator that is going to feed on the bacteria. Here, on the top, we are feeding on the bacteria, which my friend talked about. Then down, we are removing the what? The heavy metals. So this is really nice. And talked about who should buy this. I think NGOs and the government of Uganda should buy this and should purchase this for the local community, because it is really an affordable system that can save a lot of lives, because here we are saving lives. Then when you talk about the flow rate, we shall only play with the grain size. The flow rate is like that because the grain size we are using is small, but we shall adjust it. If we adjust it, the flow will be much higher. Remember, for us, we are only interested in moving the what? The metals. Yeah. So I think that is it. Then, yeah, it is affordable. It is affordable because you've seen we are using locally available materials. Then the type of sand, I think the best sand is from Lake Victoria when we are constructing biosand filters, and that one is recommended. Thank you so much.
Back to your innovation, you need to add a reservoir tank. Okay? A reservoir tank, so that after filtering, I can decide to filter in the night. So I need a reservoir tank, and I collect the water in the morning.
Yeah. Thanks so much. And last one from me, I would like you to dig deep into the biopredator that you talked about, that is eating the virus and the bacteria.
Okay, the predator, okay, so the biological layer on the top there grows naturally. When you are feeding the water, when you expose that biosand filter to air, oxygen, so the oxygen will help develop that. The oxygen plus the interaction of oxygen plus the top layer of the sand will help develop that biological layer. And it takes a period of 21 to 30 days. That is like when you are feeding water. After 21 or 30 days, that is when you can realize that really the biological layer has developed. Then how do you determine that it has really developed? Now when you get your water, the effluent from your biosand filter, you'll do some physical tests. You'll try to smell it. If the odor is good, okay, it's neutral. Water should be neutral. If it has a neutral odor, then that means our biological layer, shumudeck, has grown. It is there. Thank you so much.
Even on the prototype, if you see on the top layer, there is that layer that develops after 21 days. It is somehow elastic that consumes the bacteria.
Ladies and gentlemen, as we conclude, I wanted to advise those who haven't come on the floor yet, the presenters coming, that we have a judge's criteria that would like to see, other than the technical science, just below we are also judging the affordability of what you're presenting, of the solution. We are judging the business aspect of it, how much it will cost, who will buy it, how you will scale it in order for it to be sustainable and applicable. So when you come and focus on the science, you're going to get half of the marks, you lose the other part. So think about it before you come to present. Otherwise, later you brought it out and were able now to get it. That is very good. Thank you. Also, we need a timekeeper, I think, to know how much time each one should spend and how much time the judges should ask.
Wow, wow. Thank you so much for that presentation. It was beautiful. And a clarification on time management. Presenters, you present for 5 minutes. Judges ask questions in 2 minutes. And then you reply those questions in 3 minutes. Those are 10 minutes for presentation and everything is done. We are a little bit aggressive because we have someone to time you up. Thank you so much. Right now, we will invite our own from MUST, the critical thinkers of MUST. We are going to challenge you from our home. Make sure you are challengers. Let us have Mr. Ataho Ronnie. Please come forward. Some hand clap for our own guys behind.
A very good afternoon to you all. My name is Atahoroni, and I'm here to present to you a project named Low Risk. As we are preparing, so yesterday I was watching some news on NTV, and I happened to watch some lady who was coming from Arua going for surgery in Kampala. So she was like, the journey was so hard, the costs are so high. Remember, she had lost some breast before due to breast cancer, and now she was going for the second surgery. So it was just a mess. And the interviewer was talking to the doctor herself, and the doctor was like, most of the people that come here come when they are stage 3 and stage 4, and we have never seen a miracle that a stage 4 patient suffering from breast cancer is healed. So this is quite a very big challenge, because it's very hard for someone to come from stage 1, stage 2, stage 3 to stage 4, and then comes to realize that this is cancer. This is breast cancer. So sometimes you come to ask yourself, and why is this happening? Why do people fail to notice breast cancer at early stages? And the reasons that we have: one, that's our background. Breast cancer is the leading cause of cancer deaths worldwide, and in Uganda it is the second, with 50% of its patients surviving for 5 years. And we have actually seen that most of the people that go for testing, they go in late stages, stage 3 and stage 4, which is very hard for someone to even survive it. And then the barriers: number one, the things that we have that are limiting us from identifying these things, the breast cancer in its early stages. For example, in stage 1, the tumors are 1 centimeter to 2 centimeters long, and they are in one side. So they go on increasing in size until they are beyond 5 centimeters, leading to stage 3 and stage 4. First of all, we have the MRI. You know, the MRI is very expensive to access in Uganda. The mammogram, it doesn't work very well for dense breasts, because we the young people now, the young women have dense breasts, so it is not going to work for them. It works for ladies that are 40 years and above. Yeah. So some of these factors, I'm going to talk about the factors for the development of breast cancer. First of all, personal history. If you ever had breast cancer or not. Second of all, breast cancer and other types of cancer in
the family. If your mother or aunt or someone had breast cancer, you are at a risk of having breast cancer. Then mutations in the BRCA, these are the genes that stop the occurrence of breast cancer. Then if you are having large breasts, you are at a risk of having breast cancer. Whether they are all late pregnancies. Trust me, if you have never had a child or you have taken very long to produce, you are at a risk. What does this show? It shows that literally we almost have negligible intention on how we can easily prevent ourselves from having breast cancer. So, this is some lady from Rukunjiri. The community was collecting funds for her to go for. Now you imagine, look at the size of the lamp. Remember, stage 1 is 1 centimeter. Now the lamp has overgrown. This is even beyond stage 4. So it is a very big challenge. And from our research questions, first of all, this research paper is about the multimodal non-ionizing breast cancer detection device that is going to be even employed in low research settings. For example, this is our proposed solution. I got this design from the people that measure the brain activity. So it has very many electrodes that send in alternating electric current inside the tissue to measure the resistance, which we call electrical impedance spectroscopy. So that's one of the technologies that I'm using. Then another one is the near infrared radiation spectroscopy. This one, it is used for measuring the water content in the breast. For example, if I'm going to show you the structure of the tissue, if it is normal, you see the structure here, it's very intact. Now look at this one, where the tissue is affected. You see these spaces, electric current from the physics we studied in A level. We know electric current takes the path of least resistance. So if we inject current inside this tissue, we are going to face a small resistance to the flow of current, not like in this one, because this one we are going to have a high level of resistance. And more of the technologies that I've decided to implement in this, to add in this, is the thermography. These are some of the images. It bases on the temperatures. For example, if a tumor has, if a tissue has some tumor here, like here, they have a lot of blood, so they grow very fast, so they require a lot of blood, so they have high temperatures, and the areas around them you can see they are green, and these they are red. So this I am going to implement this one into the project. Then the tactile array. This feels like the real touch by the doctor. For example, if you are placing like on a breast, they normally say that if you are examining yourself, you maybe touch here and then you can place to feel the tumor. This does it for you. If it accesses something that is hard, then you are going to get notified. Yeah. So this is a methodology. We are going to acquire readings from the sensors, from the EIS, electrical impedance spectroscopy, the tactile array, the near infrared, and the microwave. So these signals are going to be collected and processed by the ESP32, and the ESP32 is going to be embedded with an artificial intelligence or a machine learning model that will be able to classify all these signals that we have obtained from above, and then it can give you an output risk from 0 to 100. So that's to take you a little bit back. So that's a portable, low-cost, multimodal, non-ionizing breast cancer screening companion device. It is not meant to replace these devices that are already in existence, maybe the mammogram, the MRI. So it is not meant to replace them. So for it, what it does, you can put it at any time you feel like testing yourself, because the advantage of it is it uses multiple models. It does not use one model. If one model fails, for example, if someone has some inbuilt chips inside the body, like they are for testing, maybe the heart rates, maybe something like that, the electrical impedance won't work well, because other chips are also injecting current inside, so you are going to get invalid results. Then we opt for a different technology, which is NRI, immediately. So, and if it as well fails, we go for the tactile array. So there is no way how you are going to skip getting that. Maybe you have some tissues and you need to go for screening. So this is a companion device, and it can be bought by even an individual into one's home. See it? Sorry. You can put it on. First of all, it is portable. Second of all, it uses low-cost sensors, and so it is portable. It uses low-cost technologies, low-cost sensors, and it does no harm to the body. So that's our innovation. Thank you so much. Questions?
Thank you very much. You've said it is affordable. What do you mean by affordable? How much is it?
Thanks so much, Atao, for the wonderful name for the innovation. A portable, low-cost, multimodal, and non-ionizing breast cancer screening companion device. Yeah, one point of concern, I reached a solution before seeing your literature. Possibly maybe your slides while we were presenting, they shifted. That's why maybe the proposed solution came before the literature. Two, I didn't see your sources of data. Maybe even when you are saying that cancer is the second lead killer in Uganda, maybe 50% recognize it when they are at 5 years or what? At stage 3, you didn't trust your source of data. So try to validate your presentation with data, quality data, since you are dealing with human beings. And then you also maybe possibly talk about who is this customer. You're saying individuals, at how much. Okay, thank you.
All right. Thank you for the good innovation. In terms of the technologies that you're using, you mentioned machine learning. So I'd like to know how you're training this model, why you're picking the images that are going to train the model to make the prediction. Because for you to be in position to predict, the model must have learned from information that you've collected from the past. All right, thank you.
Thank you for thinking about a challenge that is affecting us as women, which is why we think about gender balance, even as we are creating a judges panel to look at things like these when we see our breasts being exposed, you know. But thank you. I was listening as you were presenting, and I kept on thinking, what exact problem is he trying to solve? Is it failure of the available technology to detect a lump at its earliest stage, or is it that women are failing to go early enough for a checkup? Because those call for different solutions. If we are not going early, we need sensitization. If it's about the devices not detecting early, then these things apply. So I felt you were not very specific to the minute on what challenge you're trying to resolve. Then, which population are you targeting? Because we are saying young ladies' breasts are dense, then older ladies are lighter. Then so we need to know the age group this solution will apply to the most. Then I was wondering, is this your solution, this one? Is it in place? Have you prototyped it? So where did this picture come from? Did you design it, or you got the picture from somewhere? By who? You designed it. So is it in place, or this is a soft design to be created later? I thought you had taken it from somewhere, which means it already exists. But if it's your design, then that is okay. Then what is the cost? The whole business aspect, you did not bring it out. How much will it cost? Who is going to pay for it? And how will it be scaled? And then which geographical location is your research? Is it the whole world? Is it Africa? Is it East Africa, Uganda? The previous team had a village they were concentrating on. For you, which area in Uganda, geographical location, are you focusing on? If we could answer those questions, then we are good to go.
Yeah, thank you, my fellow judges, for your points of concern. Mr. Ataho, thank you so much also for the project. It's something good. This country has gone through a lot, especially mothers. My point of concern will so much be in the technical part. That design involves electronics, not so. That means if I'm to bring the health aspect, I'm assuming the person who has bought that project is going to do some cleaning, because this is something affecting the body, and you know the effect of that with time. So how have you considered the cleaning of that device? Because I know very well when water enters into that system, there will be chaos. Then the other aspect as well, I'm wondering, are you powering it externally? Does it work with a battery? Because you have spoken of sensors and microcontrolling technology behind the ESP32. So my point of concern will be, how is the powering of the system, charging externally or any other method? Yeah, thank you so much.
Thank you all for your questions. Yeah. And to start with your last question, how is it powered? I'm planning on using Lion batteries. So on the aspect of cleaning it, to be sincere, I've really not thought about it yet, but it's something I'm going to look. So the geographical location, this is basically made for the low resource settings, the villages. For example, in areas like in Barara, you can count the places that have mammograms, if at all they are there. So this can be able to be put in low resource settings, for example, in villages where people cannot easily access the mammograms. The next question is, which exact problem am I solving? The exact problem that I'm solving is failure of people in low resource settings to access these mammograms, and they maybe end up failing to go for screening in time. The people in low resource settings, even those people that are in towns, it can be a continuous checkup, because it is hazardous to expose yourself to radiations. I hope you are all aware about that. So where are you getting the data from? First of all, since it is not yet a finished product, I'm looking at getting the data from cargo, getting some data sets from cargo. Then I use them to train the model until I get these sensors. You know, some financial constraints are holding me behind. So if I can get these sensors, maybe put in extra effort and correct the data from using my actual sensors, then I can see how it behaves. Then I can be able to validate it. How much affordable? For example, I'm going to, from this aspect, I would like to maybe if we are to talk about mammograms and MRIs, quite expensive. So I'm going to create something. You see, these electrodes, the minimum number should be 32 electrodes for the electrical impedance, because I want to capture each and every part of the breast such that no lump is left behind. So it might take some big amount of money, not equal to the mammograms and MRIs, not even a third of what the mammogram can cost. Thank you so much. I hope I've answered all.
You don't have to respond to this one. You said you're getting data sets from cargo. And an AI model is as good as the data it was used on. And cargo data sets, most of them are from the Western population. Yeah. So for you to have a model that is fair and not biased, you must collect a data set within the population. Yeah. So think about that.
As we conclude with this presenter, I also want to pass on an announcement to those who are coming next. We are also interested in knowing the team you're working with. Are you a one-man team? You're still alone, eh? If you're working as a team, tell us about the team, not the names. That will take a lot of time. Just we are 5 people and we come from these different backgrounds. Or I'm a one-man person, eh? Is that we also know.
Wow, 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 wow. As a woman, I am very inspired. Thank you so much to find a male trying to look at our problems. Thank you so much. Another hand clap for him. For the next presenters, we don't want to be rude. Please summarize your presentation in 5 minutes. When you hear the bell, then know you have limited. Actually, your time is done. You literally need to summarize what you're remaining with. Personally, I would advise maybe you give us your problem, the solution, your team, and a little bit of it. The slides are there. The judges will read through so that we can save time and have a good presentation. Thank you so much. And next on our presentation, we will invite Ernest Cook and Ernest Cook University, Mr. Onyu Trevor. Please come forward. As he comes forward, guys, hand claps. Hey, these are things that inspire you to speak better. Thank you so much.
Very good afternoon, ladies and gentlemen. Onyu Trevor Isaiah is my name from Ernest Cook University. I'm here to pitch my project that I'm doing with 5 other people. We are 3 biomedical engineers, 1 electrical engineer, and a doctor. All of them are members of Ernest Cook University. This project is aimed at handling cardiorespiratory gaps. HRV, if I start by defining the term, is heart rate variability. Yes. Cardiovascular diseases have proved to be the leading cause of mortalities globally, giving us 32% of the deaths, and Africa contributing 12% to this. And Uganda stands at 2,800 people dying annually, which is really, really a bad thing. And research has shown that 65% of the people suffering from cardiovascular diseases have a history of respiratory arrhythmias. This is improper breathing or breath difficulties. And this being a very significant cause of cardiovascular diseases, we decided to come up with a project that addresses that. Current technologies in Uganda and the world at large are aiming at handling this in terms of treatment of cardiovascular diseases and monitoring of heart rates to predict. But as us, we have decided that we want to prevent the cardiovascular disease before happening, since 65% of the causes of cardiovascular diseases is due to improper breathing. Like Steve Jobs said, that simplicity always has greater impacts. As we all see, our African mothers, by God, had this wisdom that breath is related to the heart. When a child chokes, when a child is scared, they always gave them a nub. They always smoothed them, and that helped to give them proper breaths. At the end, life is saved. So, this is something that we have decided to make scientific, to make safe, to make better, because a human being does not have proper precision, but a machine can be trained to be precise. Using frequency of 0.1 Hz, we are able to create vibrations which bring cardiorespiratory resonance. That is something which makes the heart breathe, makes the lungs to function properly, open up and allow enough air in and breathe, function well. With that, the heart is able to pump blood effectively. If you try rubbing your chest, you'll notice that you're at peace, your heart is functioning well. So, we are using vibrations. This is a robotics-based project. Affordable tools. Stepper motors are very affordable, only 60,000. We have servo motors at 40,000. Though with fluctuations, we have taken an average of 50,000. We have electrode ECG leads, as we shall see forward. Right now, I just want to pitch it, then I'll take you through the slides. Yes, with ECG leads, these are very common everywhere. 60, 65, we can afford them. And with a microprocessor of 60,000, this is a very affordable project. Mass production, prototype production for this, for students, it is 250,000 at, allow me to summarize, 250,000 at UVRI, at URI. And for mass production, it will take us to 200,000. And this is a viable project for African setting, using African solutions. I hoped to go through the slides with questions as I'm answering the questions.
All right, thank you so much, Mr. Trevor and the team. I'm happy to hear you have a big field, the doctors, the engineers. So that means the effort that came up was not out of one brain or one professional field. That is good. And I'm also so excited when you start talking about heart-related matters, because many are the times we've lost our people thinking it's a joke. And we see them stretch once and somersault to death. Yeah, so this is a very important project that ought to grow. My area would be so much into technology. If this system is going to be available, I don't remember you talk about the administrative rights. Who are we considering as an administrator to monitor? Is it the doctors who will have this system? Is it the parent who is close to the victim? Something like that, so that we know when such and such an attack happens, there is someone to press the switch for the project to set off. For that, I will forward the microphone to my...
Thank you very much. You talked of the current technologies. I would love to hear what we are using currently. Then, as my colleague has said, I would love to know the usability. How easily can your device be used, and how can the results be interpreted by a person that has no medical background? Thank you.
Yeah, thanks so much, Trevor. Yeah, possibly I didn't hear, you told us about the cost of the individual components. I didn't hear about the cost of the device. Then also I would like to know whether you have a functional prototype or whether we just have an idea. Yeah. Then I would also like to know, who are your target customers? Have you segmented your customers to know that I would be selling it to hospitals or to individual households? Okay, thank you.
All right. Thank you for the brilliant innovation. What's your plan for researching this device? Yeah, because before you launch onto the market, you need to have gathered sufficient clinical evidence to show that the device works. So you need to tell us just a little bit about the plan you have to test.
Yes, and when they said we are here to judge papers, I thought these are research papers. So I'm expecting more of a research approach. The first team did it very well. We wanted to see methodologies, the data that is collected, the literature that has been reviewed. So now, as if we are seeing people come here and just tell us what the problem is and they quickly jump to a solution. I think this session is more about the research that was done before we went into the intervention. So it leaves me with some questions. Again, it's not clear what the problem is that you're trying to solve. Now I'm thinking, is it, I end up composing my own problem. Is it that cardiovascular diseases receive more of a treatment intervention rather than a preventative intervention? And so now you're coming in to cover that gap on the preventative method. I'm accurate? Yes. So you need to make it as clear as that. Then, of course, I don't know the number of people that you know have suffered, are suffering from this challenge in Uganda. It is not clear if this new intervention of yours has been applied before. You see, now the person who left here was telling us there are all these mammograms, so we know the breast is being screened, but he's coming up with a different method of doing it that is more cost effective. So this thing you are introducing, has it been used before? Do you know if it works? That you're now coming up with a better version of an already existing solution, which is also innovation in a way. And then finally, how far are you in developing this solution? Is it also an image, like the previous presenter said, it is just an image that I drew? Is it also on a drawing level, or you have developed something? If you could shed more light on that.
Thank you so much. So allow me to start with the last, from down going up. How far? Yes, we have done research, we are making, and we are at fabrication level with this. Yes. Then the application. As you can see a mother there helping a child. It has been applied before in Africa. I have seen it. We have all seen it at one point in our lives. We choked or we got scared and someone helped us breathe. Yes, it has been applied before. We are just making it safe using precision. That is what innovation is about. The problem, you got it accurately. We are trying to help people breathe so that we prevent cardiovascular diseases. The research approach, being a biomedical engineer and someone who does medical informatics, we have carried out research. I've done research in Mulago, I've done research in Mengo Hospital, and we have a compilation of data. It's just that prior information told us we are pitching in 2 minutes. That's why this is really, but I'll share my paper. Then customers, anyone, I repeat, anyone with problems, respiratory problems, asthmas, can use this. And we are so much targeting people in active environments, like those who go to the gym and those in hospitals currently. We are looking at, right now, our status is 28,000 people having cardiovascular diseases. Those are the first people we are starting with. Prototype, like I've said, we are in fabrication. The cost, these are the statistics that cardiovascular diseases have really been a menace in the world, with Africa at 12%. That is our budget. It is just 993,000, very economical. When this is produced at 200,000, we expect to sell it maybe at 250, depending on the person who buys, because the factory makes, but we have other people, you know, shops around who do that. So we don't expect it to go past. If it goes past, then we have Ugandans cheating Ugandans. Usability. We are using what we call a rule-based technology, or rule-based. For those who do robotics, you understand that very well. Yes, if your breath is at this, then you have this, either this problem or that is rule-based. Then, because it's integrated with an expert system to teach you to how to breathe, we have, like the budget shows you that we have a TTS module. It helps you really understand what to do. So this is a portable device, very portable. As you can see, that is how far our prototype is. It's really going to be a portable device. Like this photo shows you, that's what we want it to be. Then current technologies. We have quite a number of technologies, but these are wearable devices. We have SpO2 sensors, ECG sensors, a lot of them, but they are just monitoring. They are not preventing. Thank you.
Wow, definitely you can see the mastermind, how they appear to present. Thank you so much, guys. We shall be doing this for a while. And I would like the person presenting for KIU, if you can come forward and give me your name. I never received it. Right now, we'll invite the innovators, the researchers from Sorority University. Mr. Amanya Edwin, please come forward. Guys, just clap for the masterminds. Next time when you come, we'll clap for you more. Please clap for them.
Good afternoon, everybody. My name is Amanya Edwin from Sorority University, student offering Bachelor's of Engineering in Electronics and Computer Engineering. I'm here to present the paper titled A Data-Driven Framework for Addressing Structural Inequalities in Uganda's Public Health System. So, these days, there is a term they are using for data. They are calling it the new gold. They are calling it the new oil, because data has become expensive, and every system we are seeing applications, they are looking for data. So here I come to present a data-driven framework to address the inequalities in the public health system in Uganda. So the question is, can data science quantify Uganda's health inequality and guide a concrete, low-cost, corrective framework? So this is the question this research is answering. So, the research background, what prompted the study? One is observation, observing through our community the health distribution. Then the second was the literature gap. So, a detailed literature preview is in the paper. So after I will share the paper, you can read. Then the theme of the year for this also inspired it, looking for the loopholes in the health system in Uganda and how to use innovation to tackle. So those were the inspirations for the study. So what did I use? Data sources in machine learning. So I used machine learning, mainly clustering. Clustering, we group data according to the way they are related without the predetermined. So my sources, the first source was 6,520 health facilities. So this one was got from Mendeley Data Repository. So these health facilities have features like the GPS, rating, service types. Then the next was from the Uganda Bureau of Statistics, that is the population census of 2024. So where I picked the sub-county level population. Then finally, the district boundaries. The sources is the simple maps. So, after performing clustering, I'm not going to take you through the process, the technicality of clustering, but these were the results. So, the first figure is representing the hospital distribution by cluster. So, I clustered the data I got and the population, the rating, and in according to 4 clusters. So, these clusters were the central region, western region, northern region, and the eastern region. And the graph clearly shows an inequality in the distribution with over 79.4% of health facilities located in the central region. And when you check on aside, this is the plot showing where the different health facilities according to the data I was using. So furthermore, these are the care system distribution. who owns the health facilities in Uganda? We have the government, then the PF, which is the private, then the non-government, which is the PNF. Those are the non-governmental organizations. As we check from the bottom, it is representing the government. These are the stakeholders, showing that if you develop a system, these are the people who can help in facilitating and funding. So the map here is showing the clusters. Where you see a plus, we call them centroids for our clusters in clustering. So this shows that most of in the other regions apart from the central, the government is the leading caretaker for the public health. So through the analysis, these are the two loopholes we present. The first loophole is the geographical maldistribution. After seeing the graphs, it is showing that over 74%, that means 79.4, that means only 20.6 is left for the, okay. Let me try to summarize. Then the second loophole is the data blind. So how to solve these loopholes? We are coming up with a system called the EquiHealth system. So this system, how is it addressing? First of all, loophole 1, we are addressing it with an EquiMap. This is the GIS cold zone dashboard, or GIS is the geographical information system. For it, it manages data in relation to the maps. So it manages, and also then plus what we are calling the EquiReach, or the telemedicine network. So our EquiHealth system, for it, after being built, will be synced to the EquiHealth system. This is an application which can be stored on a smartphone, mainly for the community health workers, the VHTs. So in case they are in the villages trying to carry out research and also to provide information, they can easily update our information, also get assistance from the professionals who will be linked to the EquiHealth. So how is this aligned with the policies we know? The Sustainable Development Goals. It is aligned with the third one, which is the global health and well-being. And also the National Development Plan, that is the third one, which was for 2025. So the pillar for it is equitable service delivery. Here we are trying to create the equitable service delivery. Then the Vision 2040, the Uganda's long-term blueprint. So transform Uganda to a modern prosperity. There, one of the pillars is equitable service delivery. So it is aligned with these policies. So also there is international, it is also globally feasible. We are seeing countries like in Kenya, they have used the global information system to map the malaria issue, plus the reference South Africa and Namibia. So this is the roadmap, the phase 1, prototype, then integration with the district health information system, then national scaling. That is the implementation roadmap. So finally, that is the conclusion. Thank you.
Thank you very much. If you can go to the second last slide. What is the point of interaction of EquiHealth from phase 1 to district health management information system, and then HMIS? Because I understand from the district that information has to be fed to the national management information system, which is the health management information system. So what is the point of interaction of your system and the already existing system? Another question is, you talked of involving the community health workers, the VHTs, at the village level. To what extent will they understand your system and how will they be involved? I also want to appreciate you tried showing the data sources where you got the information from, which is very encouraging. And I can leave the rest of the questions to our colleagues.
Yeah, thank you so much. I appreciate the initiative, especially with data. I'm a bit inquisitive on how you'll separate what is false from what is true, because we have a lot of misrepresented data from some of these trusted sources. Then I later realized somewhere in your slides when you're talking about the distribution, what was running in my head, how these the hospital clusters are clustered. If you follow the population and the bias, you see that much of the hospitals are distributed in the central region. I think this thing is as a result of the number of people or the population around. So somewhat, don't push the bias. I request you don't push the bias so much in the central system, because the population, I think, has something to play with the distribution in the clusters. And then somewhere I would also request you be a bit clear on patient or some privacy, because there are some issues here that don't need to fly, that may cause panic in a nation. When you hear, for example, issues that concern Ebola, you get it. When such information is sometimes publicly dropped, it may cause a wild panic, like the issue that happened with COVID. So I don't know how your system will help in the exposure of such things to prevent a catastrophe that may occur as an effect. That's all from me.
Thanks so much, Mr. Amanya. Yeah, I liked your flow of the presentation. It is so organized. I, however, haven't noticed who is that you're getting to be your customer, and at how much, in case you're to implement the equi-health system. How do you intend to make money? Because we have seen from your presentation, the biggest proprietor is government. So are you going to work with the Ministry of Health? Are you going to work with the government? And how do you intend to make sure that this system, the equi-health system, reaches more users? We are over 40 million Ugandans. How do you intend to reach all this population?
Yeah, thank you so much for the good presentation and nice idea. When you started making this presentation, I was quite impressed, and I was looking forward to the framework that you have created to address the structural inequalities. So at the end of your presentation, I thought I would see a whole framework that you have identified these factors, and this is the framework that you have built to address the inequalities. So if you can respond to that, on how you're going to use the data to address the different inequalities in terms of the framework that you built.
Yes, I like that you have aligned your research to all the goals, the Sustainable Development Goals, the National Development Goals. It is always good for those who are coming to align to those global interventions. I'm still having a challenge with the problem statement, and I want to recommend that from here, for the future events to come, we do a capacity building on problem statement. Because if you get that wrong, you will struggle in future with all the interventions. It needs to be simple and clear. So for me, I'm thinking, are you saying that there's poor or inadequate distribution of health data in different regions in Uganda? Is that what it is, or I'm getting it wrong? You'll answer that question. Then also, who is complaining? That is what my colleague was asking. Who is this person who wants our solution and is struggling to get the data? That person did not come out. Is it the health workers? Is it the government recording people? Who is complaining that this thing is inadequate? we want to know, and if they are few, it may not matter so much that we invest in solving their problem. But if there are many people complaining, then it is worth funding and paying attention to. That's why we want to know who is complaining and how many are they. And then finally, how much will it cost if I want to buy this system and install it in Western Uganda? How much money will I need to pay in order to do that? I think those are my few questions. Thank you.
Thank you very much, the judges, for the questions. So the first question I'm going to answer, he asked the point for the district health information system integration. What is the main point for the integration? So the main point is the district health information system has the information about LSA for previous years. So it is better to integrate with those information which are not publicly right now, unless you have the required permission. So that is the reason for the integration. Then to what extent the community health workers, how will they be involved? Our third phase is there to deploy, but also and training the caretakers. So the community health workers will need to be trained. So, but on the phase one, there will be pilot. So this one to see, is it really working? So we shall train maybe one, or we'll train some few. So that is in phase one. Then how to differentiate the information if it is false or true. So the more we do machine learning or the data science, there are some sources which are trusted. So I trusted Mendeley for the LSA. Then for the population, I had to go to the UBOS. We went to the UBOS, the Uganda Bureau of Statistics website. The information about the population census is there and downloadable by everyone. So those are more trustworthy. Then the issue of the information being biased. Yes, may be biased due to the population, but the population was the clustering. When clustering, we didn't include the population. For it was to get the further characteristics of the cluster. So also there is, so for the population was to get the secondary characteristics for each cluster to get the population burden. So the privacy part. So the GIS has been used for in other countries, like even to combat the COVID, to check for the spread. So this can really create the panic. So for privacy, for things which could create panic, needs professionals, so to guide in which information should be displayed publicly. Then how the framework responds to the inequalities was the next question. So how the framework responds to the inequalities. So one, so when you integrate the Equimap, or which we to identify the cold zones. So like if you look at the map, this map, we are seeing there are some areas, like this is Karamoja region. Those are now cold zones. They are barely having no data collected or no health facility. So this one can help in other people to compare with the population. For example, I'm going to answer it with who is in charge. Can we fund now the private investors and non-governmental organization? Also them, they are tending much to invest in areas with more. But if there could be a public system where they could see, they could change, somebody may change a mindset. Instead of putting my LSA facility in this crowded area, let me take it this side for a private investor. That means a private investor may gain more to see how to invest. I can quote the speech of His Excellency. There's that speech where he said he found a very big beer factory here. Then he asked how, and they told him the South Africans told him we had data. So they were private investors. So also, other private investors may see these are not cold zones and invest in places which will make them have more income. So those were the questions. Thank you. I would like to thank Madam for clarifying on the problem statement. We shall work on it. Thank you.
Wow, thank you so much. I think this presentation gave us something to think about, something to retain in our minds. And lastly, but not the least, we shall have KIU represented by Ikorupis. Miss Ikorupis, please come forward as she comes over. Guys, again.
Good afternoon, everyone. Good afternoon, everyone. Good afternoon. My name is Ikorupis. I'm a student of Kampala International University. I'm doing a Bachelor of Science in Mechanical Engineering. I am so glad to be in the presence of all these amazing engineers and the next engineers to come. So I am part of a group of 5. Our group is called Group Susano. It is based on our project. The name is based on our project. So today we are going to talk about loopholes within the public health sector and how we can use innovation to solve them. First of all, I would like us to understand what public health is. Now, public health is the science and practice of protecting and improving the health of communities. We are talking about things of disease prevention, promoting healthy lifestyles, and prolonging people's lives. And this can be done through health education, safety practices. And now we have also realized that as engineers, we can also put in through innovation. Now, why should we all care about health, about public health? There are a lot of challenges that our health system is facing, and we are going to see them. So I would like us to imagine a scenario. Think of a mother who is living in a rural area. Let's say she's living in Kamuli, and she has a sick child in her hands, and the nearest health facility is miles away. And so she takes all her efforts to ensure that she reaches to that health facility because she wants her child to be treated. But when she reaches there, there is no electricity, the doctor is not around, all the health workers are not around. So today I want us to think, how can we help this mother? How can we help people who go through such situations? So now, this scenario brings us into a very important loophole within our public health system, and that is inadequate and unreliable infrastructure. Most times, people consider infrastructure to be in terms of roads, buildings, and any other thing, but As engineers, I want us to think of infrastructure to be more than just buildings, to be more than just roads. Let it be what is within the buildings. We are talking about things of electricity. One of the biggest challenges I have realized that we face is electricity. And in the public health sector, that is not the only challenge we face. There is unreliable electricity supply in rural areas and even developing towns. We have frequent power outages. We have limited backup systems in the hospitals. We have inadequate facility designs and overcrowding in these places. And a lot of these consequences that come from these challenges that are faced. So let's assume that this is not a logistical problem. Electricity is not a logistical problem. It is a problem that engineers need to think of and find a way to solve it. So now, imagine that it was your mother who had gone to the hospital, and while she's in a surgery, there was a blackout. So we are going to look at an innovative solution. So we carried out an interview with a doctor from Kampala International University, and we realized that really electricity is one major issue in hospitals. And we also carried out an interview with one of the residents in the local area, that is in Refrigerated. She told us that there was a period of time in Refrigerated where there was no electricity and there were a lot of dark places. So if we are thinking about public health and how to help people, we need to think about how to keep them safe. So if we could ensure safety in those streets by providing them with lights on the streets, that would be a very good way. Because some time back in Refrigerated, there were people who had started to kill people who would move late in the night. So, and they would do that in dark places. Now, because of this, we have come up with our project. So, ladies and gentlemen, I'd like to introduce you to our project. It's called Project Susano. It is a project we are aiming at doing one thing. We are aiming at doing one thing. Sorry. Our project is aimed majorly at one thing, that is producing electricity. So, have you ever wondered how many footsteps each of you takes in one day? How many footsteps do you take while walking to a nearby shop? How many footsteps do you take while going to the hospital? Have you ever wondered? Now, we all know as engineers, one thing that energy can never be destroyed. And so, as you move, you're having kinetic energy. And so we want to pick this kinetic energy and use it in a different way, to put it into importance, because you're just moving around, and apart from it helping your health, there is nothing else it's doing. So we are going to transfer this. We're going to transfer this kinetic energy into electrical energy through our project. I mentioned I have a team, and that is our team. Excuse me for a minute. So our project is based on a material that is known as a piezoelectric material. It's having a piezoelectric sensors, and piezoelectric sensors are devices that convert mechanical stresses. We are talking about things like pressure, vibrations, and force into electrical signals. Meaning, while you're working, and let's say there was somebody you're working on, there is a pressure that you will apply on this person when you're working on them. So we are using that pressure to help us transfer the energy that you were having into electrical energy. This is a simple diagram of what our design looks like. We are planning on incorporating piezoelectric sensors. And below is a simple block diagram. I'm sorry for taking extra time. Below is a simple block diagram of our design, and in case you would want to see it in practice, please feel free, because we have worked on it and it's functioning. Thank you. We also had a graph that we drew to help us show you how much electricity is produced, and also a pie chart. Allow me to show it to you. This is our pie chart. So for heavy steps, we are having about 50 to 80 millivolts that are produced, and for light steps, we are having 30 to 50 millivolts produced, and in heavy traffic areas, about 80 to 150 millivolts that are produced. So if you happen to have our piezoelectric tiles in a place that has a high foot traffic, let's say places like stadiums, malls, or institutions, you can produce electricity that you can store in batteries to use for later purposes. For future considerations, like I said, using them on a large scale, like in airports and shopping malls or taxi stops. And we can also, because our project, when you go there to see it, we are using wooden tiles. So we can use that to transition from, we can also transition from use of wooden tiles into polymers that are way lighter. If we use polymers, we are able to incorporate this idea into different forms. We are talking about carpets, clothing, or even shoes that can help us to generate electricity. Thank you so much for the time that you have given me.
They are giving me the microphone to start, probably because of gender issues. We have our First Lady presenting. Let's give her a round of applause. Thank you so much. A few comments. One, I think you should scale it down to exactly what you're trying to say. When you started with public health sector, it felt big and it means something different. Then we were down to public health facilities, then down to electricity. It was a long journey. You would have just started with electricity problems in our public health facilities. Then it's clear and we start from there. Then again, that one is also wide. Electricity is a wide area what exactly is it? So you could also scale down to that. I also want to recommend, I don't know if someone here is taking recommendations for the future. We have someone from MUES taking recommendations. This is my third recommendation, and it is that when the presenters are going to, the people selected to present should prepare their presentations and then practice like 8 times. That way you stand before us and you know where each slide is, you know which slide is coming next, you know what you're saying. Even if power disappeared, the flow is in your head. So keep that in mind. I feel the presenter was looking for this, looking for that, stopping for this, stopping for that. It becomes hard for the judges. Then I would also advise that you always find a technical person to explain the science of things. You can't tell it like a story. Science is science, you know. I'm not of a science background, but Martin is, someone is, so they may challenge you. Bring an electrical person to explain the science in electricity and how it's going to work. And then also, yes, what number of health facilities have you identified that are struggling with this problem? What interventions have been tried already that you are now challenging to bring in the walking shoes or the kinetic walking energy? Then I also didn't understand how that solution applies directly to the problem. I didn't get the connection of the energy from the feet going to feed into the hospital. I felt there was a gap there. I think my colleagues will be able to add to that.
Yeah, thanks so much, team. Susano. Yeah. Actually, when I read your title, I was like, possibly you need a full ministry to handle public health. Yeah, so our co-judge has actually highlighted most of the things. So I heard about safety, I heard about darkness, I heard about electricity, I heard about manpower, facility design. So it was a whole big story, the Big Bang. So possibly if we can always narrow it down. And then I didn't see data. I didn't see data in your presentation. Yes, we had cases of maybe people being lobed in dark spots. However, we didn't have the data, what supports our claim. Okay? Yeah, so possibly if you could next time work on that. I think it is a recommendation, not a question. It would make your presentation better. Thank you.
Team Susano, Project Susano, thank you so much for your presentation. I greatly appreciate. You started from a very big scope. As my brain was still rubbing around, you narrowed the scope for me. And as you narrowed, I started listening, hearing what I understand best. Millivolts. One of the issues with designing systems that concern power is how you manipulate voltage and current. I was not certain by what law you are multiplying the voltage. Yes, yes, I see voltage regulators, I see voltage multipliers and the stores, but I've not heard anything about the power, the voltage, the power consumed, power generated. You may talk millivolts, but there is something called power factor. And that is what exactly takes us back to why other systems may be failing. Not only disappearing, but hospital or facility matters consume too much voltage. So I'm so concerned about the final output. Your input is in millivolts, but the machines you're using are going to consume in voltages that are higher than milli. So I'll be so much concerned about that area. Then the other aspect is When you start talking about the problem you're solving in terms of piezoelectric effect, what happened with the solar and any other method of electrical production that have come to mitigate the same problem? I'm forced to think that you didn't consider available systems and how they have tried to solve that problem. So I would suggest that you try to follow that footstep to help improve on your solution. Thank you so much.
Thank you, Susano. One, you began by telling us that you talked with some, I think, one of the staff from KIU. I don't know if KIU was your case study. Secondly, your solution or innovation is not feasible. Like, you can't break it down into that, lower level, and you're like, how do you implement it? So you have to look at the feasibility of the solution. Then if you get to understand how feasible it is, then you can break it down how someone can afford it. If you're looking at the government taking it up, what is the affordability, and why do we have the current issue with electricity, even besides we having generating power itself? My general comment is about the presentations in general. At times when you have visuals in your slides, depending on who you're looking at them, they can put someone off. You have slides that have different formatting, so they have to be uniform, and you have to mind about the colors you use so that some colors, they strain the eyes. So in general, we have to think about how we do format our slides and presentations. And like my colleague said, my recommendation is before we present, maybe someone should go through the presentation several times so that you get to understand exactly what you're presenting. Maybe a supervisor at the university level or someone who is hosting such an event can have your presentations beforehand, look at them, then provide clear guidelines on how to move forward. Otherwise, this is a very learning experience for both of us, and I appreciate your efforts. Thank you.
Thank you so much. Somebody asked me to scale down what our the major problem that we are trying to solve. She wants to know sorry, but allow me to ask her to rephrase that question. I don't know, was it a question or just a recommendation? Okay. Okay, then, thank you.
Definitely, this was the best. Like in high school, they used to be like, that girl is beauty with brains. I think we've seen that here again. It's nice to experience that again. And right now, we are going to another session. But first of all, I want to thank for the people who have presented. Thank you for being bold. Thank you for being innovators and researchers and critical thinkers. Thank you so much. Let's give them a clap. Let's thank our judges for that day. Guys, let it get louder. Right now, this is an interesting session of interaction. Get to know each other. We have different universities here. Get to know someone from another university. Interact as the DJ gives us some slow kind of music, and we interact. And definitely you can share anything if you want to share with us as we have this session. Thank you so much.
I'm going to announce the top project from each university, and they're going to be preparing themselves to pitch to us. So please pay attention and listen for your project, yeah? So from Ernest Cook University, we're going to have low-effective self-disinfecting presenting to us and pitching to us their project. Then from Deja University, we are going to have the resonating transformer. Then from Kadogo Polytechnic, we're going to have cultivating trader and driller. Then from Barra University of Science and Technology, we're going to have IoT-based water leakage detection. From KIU, we are going to have Project Susano. From Kawale University, we are going to have revolutionized hybrid thermal incubator. From Sorority University, we are going to have mindset and AI-based. Yeah, so those are the projects that are going to be pitching to us. I suggest you plan properly and prepare yourselves. And as you prepare yourselves, I'd like to invite a young entrepreneur who has earned from research and innovation. She's the CEO of Hatchright, Madam Anna Assumpta. Please make your way forward and give us a short speech about your achievements. Thank you.
Thank you so much. Good afternoon, ladies and gentlemen. Good afternoon. I want to hear some energy. I know we are young people. Good afternoon. Are you well? I'm so happy to be here and honored. I'm so happy to be part of this annual Innovation Week for 2026. Thank you for inviting me. And I'm Nakalema Assumpta. I don't know if anyone knows me, but I am an agri-tech innovator and CEO of Hatchright. Hatchright is a company here in Uganda that deals in manufacturing poultry products like egg incubators, brooding systems. These systems are integrated here in Uganda and made here. I had submitted my video, but unfortunately, I don't think it's going to be played. As a youth that is in innovation, I'm so happy to see like-minded people in the room and that are young people. In the East African community, I'm the one who represents Uganda in information systems, and I'm really happy to be here. A few years back, I was here in Barra University doing information technology, and I remember myself taking part in such an event. But by then, I was just a student. I'm informed that this is an engineering, engineering innovation week. I did information technology, but my innovation was in engineering. I don't know whether my sound. Yeah, but my innovation was in engineering. That's why I took part. As a student, really, for me it was, since my innovation is in agriculture, it was part of my research. Like they gave us coursework. And then I, did research and developed a prototype that was an egg incubator. I don't know whether any of you know what an egg incubator is, but it is an artificial environment provided for eggs to hatch. That is poultry eggs. So yes, as as a student, I did a prototype and I presented it in such an occasion. From that occasion, I received comments from my supervisors, and also I remember by then it was the best at the end of the year. Like we have a course unit that is for projects, so it was the best. After that, I really, after university, I graduated last year. After university, I had an opportunity to scale it up. It wasn't really from, as a person, I really liked, I'm an entrepreneur, but I wasn't into agriculture. But I had friends that pushed me to apply for certain calls. And one of my friends had applied for a challenge called IUT Africa. I don't know whether any of us has heard about it. Has anyone heard about it? IUT Africa Challenge. Yes, so I applied for IUT Africa Challenge. That was in 2024 at the end of the year. And I managed to be the overall winner for IUT Africa Challenge 2024. Why am I telling you this? Because I really didn't have a passion in agriculture as a person, but engineering pushed me into participating in agriculture. And with that grant, I was able to scale my prototype to a product that is right now registered with UNBS, and that has turned into a company that is Hatchright. Hatchright is right now has right now impacted over 1,000 farmers, not only in Uganda but East Africa at large, in just a space of 1 year. And not only that, I have been able to employ people. I'm working with some students here. One of them is Ayabaziwe Marvin. I don't know whether he's around, but he's one of the people that we are employing as Hatchright. And for me, that is something that has been a game changer. I'm not just saying all that to maybe show off of what we have, but what we have come up with, but to encourage someone here who is innovating, and maybe you have not had the money, because I believe, as a person, I believe it is beyond money. You need to prepare in many ways for you to be a better innovator. Like I said, I did not start with money, I started with what I have. So I would encourage you, as I'm ending, young youths that are in this room, start. I know most of you have started, but once you start, you must have the resilience to make sure that you're going to push this thing to where you want you to be. If you do not have a vision for your product, or if, for example, your product is not solving a real problem, then it is not going to, you're going to lose morale for you to push it. But once you see it have impact on people, you're going to have morale to push it to the next level. The reason why Hatchright right now is a company is because it was a real problem that farmers were facing. Many farmers, Uganda's poultry production at the moment is dominated by smallholder farmers. Around 80% of poultry production is in Uganda is from smallholder farmers, and for me, that was a very big gap that I had to fill. Meaning, there was need for my product. So, as a youth, when you're innovating, you have to make sure that your product is relevant or it is solving a real problem in the community. Then also building for people. Let's say I've not been around while you are presenting your products, but I'll still give you an example of my project, the Hatchright Incubator. It was solving a problem for the smallholder farmers, and I had to make sure that it is easy for the farmer. Like I developed it with the farmer. I had to go to the market, to the field, and interview different farmers of what they really exactly wanted. And with that information, I was able to come up with a product that is easy to use for a farmer that is even in the village. So as innovators, please build for the people that are going to use your products. Then also being patient. As youths, we tend to want things to run very fast. So of course, who doesn't want to see things run very fast or earn money like very fast? But if nothing happens like very fast, they normally say that ebirungi biri mass or something like that. Or for example, if you do not like I can give you an example of like a child. It is formed in their mother's in their mother's wombs after 9 months. You see, it is a process. So if you want to build something that is going to impact generations, you must be patient. And then also knowledge. You must have knowledge and and master what you are innovating. I'll give you as a lady. When I was innovating, I had issues. Like I told you, I did information technology, but my product was in engineering, yeah? And the engineering part was more of electrical and mechanical engineering. And because I did not have enough skills, I found a lot of challenges working with the electrical engineers, either through being overly charged or being taken for granted, especially because I did not have the knowledge. But once I found out that, I had to make sure that I learn. And as we speak, right now I know how to do the incubator from scratch, from cutting the wood to welding to doing anything, to connecting the electricals that are in the incubator. So what am I saying is, if you know, especially the ladies that are here, I'm not, gentlemen, forgive me, I'm not speaking because I'm gender biased, but no, I've seen a space, I've seen a very big space between ladies that are in innovation and the gentlemen. So master what you're doing. Otherwise, people are going to use it, and you lose out a lot. So when you master, once you master what you're innovating, once you have it in your hands, you will easily work with other people. I'm not saying that once you master it, you're not going to work with people. No, but once you master it, even working with people will be easier. Right now, like I told you, I'm employing over 10 people, and it doesn't mean that I do not know what I'm supposed to do. It means that I help them also, I make decisions better. Yes. Then also, finally, as innovators, we have a very big part to play in the economy, not of Uganda only, but even in the future. I've noticed most youth run for money, and business is just beyond money, because at the end of the day, an innovation is going to turn into a business or a company or an organization. I'm an advocate for innovations that are going to last for generations. Do not just build for yourself, but rather have the knowledge, get the knowledge of, if for example I register a company, do not just register a company just to run for a certain grant. No, but register a company to make sure that you're going to learn how to make it, impact generations, even when you're from the world, when you're away from the world. Yeah, most times I've been doing research, and I've noticed in Uganda there are few companies that last longer. At least for now, I just know like Uganda Walad, which has, gone for generations and generations. And that is a really big problem. As youths in this room, I would want to call upon you, that as you're innovating, do not just solve a problem for yourself alone, but think about your children, your children's children, and great-grandchildren. Yeah? Make sure that you learn what does it need. You learn beyond yourself. What does it need for me to build a legacy that is going to solve problems for people that are going to come at every moment? Once you do that, I've noticed you think about the person who, for example, discovered electricity and all that. Up to now, we are still benefiting from that person. So as youths, please, let's not just innovate for ourselves, but for generations that are coming. Thank you so much. For God and my country.
Thank you so much for that. So I would like to call upon the man who has been in charge of today, who has been in charge of organizing this whole week, our Research and Innovation Secretary, Mr. Mpumuza Jordan.
Guys, another round of applause. Good afternoon, ladies and gentlemen. My name is Jordan Mpumuza. I'm the Research and Innovation Secretary of Bara University Engineering Society, and my department, whoever is within the room, is part of the main reason why we are here today. We sat down together with our committee, the top cabinet of this association, and we came up with an idea to bring up something new on board, because usually we had an innovation week which would bring together only math students, but we decided to bring something new, because we know that we are engineers, and it's not only us that have the capacity and the knowledge to make the world better, but all of you within this room, whichever university you're from, whichever place you're from, we all have the potential to change the world today. We understand that as Uganda, we are deemed as a third world country, but as you can see, if you went within the exhibitions today, people have projects. There is a lot that people can put into place, just a matter of us looking within ourselves and picking that inspiration, even though we are copying someone else's project that has already been done, but we start from somewhere. Thank you so much. I think I would like to end here and give the mic back to the presenter. Thank you so much.
Thank you, Jordan, for that. So now we are going to proceed with pitching of projects. So I would like to call upon the first team which is going to pitch, which is going to be the team from Ernest Cook University. Please come forward so that we can pitch. The judges, we are going to give the papers to the judges who are going to judge you. Yeah. For the coming teams, we have been informed that you have to present your prototypes. So if names were read before, please go and organize yourselves and bring the prototypes. And as the teams organize themselves, I'd like to recognize the presence of our Deputy Vice Chancellor, Mr. Joseph Ngonzi, and our Dean, Mr. Obongo Loch. Thank you.
Let me first fix it.
Please, if they read your project, the judging criteria was we were choosing the best project from each university to come and present. According to the judges, they graded and we picked the best project from each university. Is that okay? So the projects we read out from each university will be the projects to present on the final stage, and it is what we shall follow to give the awarding. Then clarity number 2, the judges are seated here on the panel. In the first step, our lecturers presented their judges. So every lecturer here had to meet their university and they graded. Yes. However, he did not meet it alone. Other lecturers from different universities had to meet the different projects. So all universities were presented in the exhibition stage and everyone was equally represented. So now, the judges that are in front of us, the first person is Mr. Alex. Mr. Alex is from Terra Magica Brands. Terra Magica Brands is not associated to any university. Is that okay? We have Mr. Polycarp, who is from Fundibots, Uganda. We have Mr. Octavius, who is from Fundibots, Uganda. We have Mr. Martin from a project of under CITT,
Center for Innovation and Technology Transfer, that is in Makerere University, is in Mbarara University, different universities across the country. We have Madam Lydia, Miss Lydia, who is who heads a project called UCOBS. So all these people are not affiliated to any university. Is that okay? So at this stage, they are judging with experience. They know because they have been in the field and they have not met this project before. So dear participants, you are presenting afresh to the new judges. We shall not have any bias of we met our lecturer, he gave us more marks. No, we are presenting totally to company personnel who know and are fair in what they are doing. Otherwise, I wish to thank you for this. Thank you so much, and let's listen in from our presenters.
Thank you so much. My name is Sentongo Sudesh from Anis Cook University. Yeah, and our project is a low-cost, effective, self-disinfecting refrigerated centrifuge. Yeah, so, you know, centrifuges in hospitals are very important because in order to identify the diseases you're suffering from, when you go into a hospital, the first thing they do is getting a blood sample from your body. But where is that sample taken? And how are they going to use it to get the disease? So they get the sample from your body, it is put into a test tube and placed into a device like that one. But different samples run on different temperatures while you're centrifuging them. There are reasons why. And then our centrifuge contains a refrigerating system, meaning we're able to adjust the temperature while we're running the sample. So if the sample is blood and you put it in such a centrifuge, you set the temperature. After setting the temperature, you set the speed at which the centrifuge is going to run, and then after, you set a timer. The time that you want the sample to run in the centrifuge. When you centrifuge blood, we are able to identify plasma, red blood cells, and white blood cells. Yeah, using those components, in order to put under a microscope and identify whatever is in your blood and what you're suffering from, we have to first centrifuge. So what is the difference between our device and other devices? You know, the name low cost means we can produce this on a large scale at a low cost. The standard centrifuges cost, in hospitals, a refrigerated centrifuge costs around 18 million Ugandan shillings, the limited one. But ours, we are able to come up with a sample that has refrigeration and then disinfection. Why would we disinfect? When a doctor runs a sample in a centrifuge, they have to open and remove the sample. But when they open, there are fumes that come out of the centrifuge. Fumes that can't be seen. But the fumes, you don't know what sample you've put in there. What if the sample contains TB, hepatitis? You know? What if you inhale the gases from the centrifuge? That is dangerous. So our system, after centrifuging, it will disinfect. So the air coming out of the centrifuge is now safe. Yeah. So you can listen from a colleague.
A good afternoon. So from where he has stopped, we believe that access to healthcare tools and diagnostic equipment should not have to depend on geography or a budget. And therefore, our objectives in this is to make sure that we target the good will, health, and well-being of the personnel in the medical healthcare systems, so as they are able to do their jobs right, and to also make it accessible for low-resource settings, even as Uganda and also the deep areas of Uganda, where we come from, because most times we import these devices, and it's also to patronize our country, because most times we import these devices and they come in quite costly, so they're not able to reach some health centers. So our competitive advantage is that we have integrated it with a refrigerating system, because some samples are temperature sensitive and they need that. And it's low cost, it's affordable, and our because we also lack integrated sterilization systems where we use UV light And UV light affects the outcome of the samples, which also affects the digital literacy and results. Would like to make an illustration, maybe for those who didn't get a chance to see the other side.
So, I would like one of the judges to at least come and see us run the project. Okay. Thank you. So we've been warned that we have 1 minute, so you power it on. Like I told you, we set the temperature, and then after setting the temperature, we set the speed is in rotations per minute. So that is 3,000. And then we set a timer. Our time is in minutes, so I'm going to set about 10 minutes. The centrifugation has started, but we don't have to wait for the 10 minutes. But you see, this knob has gears. As the centrifugation is taking place, the gears take back this knob to this position. So when it reaches that position, you've seen the speed reduce. So when it stops, you press here, the disinfecting, but you see we are standing this side, so you don't know whether the disinfection is taking place. So what did you do about that? You're seeing blue light. So as a medical personnel, it tells you that, hey, doctor, don't open. It is disinfecting, you know? But doctor, you need to press more to increase the amount of disinfectant entering the centrifuge. Yeah, so you press more because you're hearing that the pressure is increasing, meaning more of the disinfectant is going inside. So you press more. We put a maximum of 5 presses. So when it is done, now you can open it. You're seeing the fumes coming out. The reason as to why you can see those fumes is because there is some moisture. But usually, if there is no disinfection, the fumes can come out, but they are colorless fumes. You're not going to be able to see the fumes. You're in a medical lab, you have a mask, but the fumes are going in the environment of the laboratory. So when you remove the mask, you will later inhale the fumes, and you will become sick. Yes, thank you.
So, thank you. Up next, you're going to have the revolutionized hybrid thermal incubator from Kavala University. And as you're pitching, please be reminded that you're going to use a maximum of 5 minutes. So try to summarize your pitching into that time. Thank you. As we wait for the team from Kavala University to organize themselves, is there a team that is already set to pitch? They can be using this time. And if not, I would like to also urge the team from Deja to also prepare themselves because they are going to present after the team from Kabali. Thank you.
Nerekereza ng'omutima omugaziira nze ne ngubikulaye abanjagaliza ne bansibula Mukama ne musaba nnyo oluno oluleme kunsalaye
University, we are having a project which is a revolutionized hybrid thermal incubator. Most farmers in the villages who do not access grid, this is the electricity, or they opt for using charcoal, which emit carbon dioxide. Those are toxic gases which destroy the ozone layer. Others opt for solar PV systems, which use batteries, and batteries are huge and expensive, and those solar systems are robust. It is a very big system. So we opted for a thermal system which uses, we use energy from the sun, store it in form of heat, release it in form of heat. Most systems rely on the sun, but in the evening, at night, the sun is not there. So we saw that problem, we sat down, and we are supposed to consume this heat energy from the sun. So we designed, our innovation is all about designing the material that can absorb the heat during the day and release the heat during the night when it is required. So that is where our fundamental of this project is standing. Designing a material during the day, it is absorbing the heat. During the night, when the sun is gone and the radiations are no longer hitting the system, now the materials that used to store the heat are now releasing the heat in a controlled way, feeding our incubator. So here we are not relying on the grid, we are eliminating the grid, which is expensive in terms of cost, using electricity units for 21 days non-stop. We are reducing that cost, and most times the grid, you will be there and you see that there will be a power shutdown for like 1 day, and the incubator will not be receiving the necessary conditions, which will be destroying the eggs. Thus, as supporting the farmers with a reliable system, clean energy, to come and solve the problems. And as per the Uganda development plan for the 40 years, it is all about industrializing agriculture and developing the rural farmers who can't access the grid. So we shall have solved that problem. We are using clean energy. We shall be fighting hunger problems. So we shall have solved the problems of the farmers using this system. So now when we go to the hybrid part, we know that the sun, it is all based about the conditions and the evolution of the earth at its axis. So sometimes the sun may delay to come. So we opted for the hybrid or the two-way, whereby we shall be depending on this small panel now to be powering we have some incandescent lights inside that produce the heat. Right now we are depending on incandescent lights because we are not yet put the collector on the sun this morning. So right now that's what we are using, and we have just started it right now. So that's why you're seeing the temperatures are still increasing until they reach 37, which is the optimum. So we have control ways which will be switching from the solar thermal to the solar PV where required. If heat is not enough, switch to the solar PV system. That's all about our project.
Thank you, the team from Kavale. So I think we'll have the team from Kadogo Polytechnic. They've been ready. They can make their way forward and present to us, followed by Ndeja University. Ndeja University, I hope you're organizing yourselves. Thank you.
I take this great opportunity and gratitude to welcome you all to this MUES Innovation Week 2026. My name is Chiza Gilbert from Kadogo Community Polytechnic, marking Barracks 2nd Division, Mbarara. We are here to present to you our projects as far as innovation is concerned, and we came out with different innovations, and of which these two have teamed up to hit the climax today. So, as innovation is concerned and basing on the problems and challenges around the community, we saw and analyzed that the machinery around the environment and the country at large is using fuel. Fuel in types of petrol, diesel, gasoline, and other types. And we came up with an idea of transforming fuel machinery to electrical machinery to make machines that can use electricity instead of using fuel. Why? Fuel, when burnt, it produces toxic gases, for example, carbon monoxide, and of which it is of high percentage, and it is so reactive on destroying the ozone layer, hence climatic change. So to sort out that problem, we came up with this idea of using electricity, and we tried to design out some modules that can really portray, if it is a bigger machine, how it would be operating using electricity. Yeah. So we have two projects here. There is one which is a cultivating tractor and a drilling tractor. All of these work very well. They have no programming. We use manual switches. And when they are advanced, all the other control from a side can be installed inside, and you can control it as you always drive your car or operate any other machine. So we are going to operate for you gradually, although some of you won't see, but they do work effectively. So this one here is a cultivating tractor which can move, turn the tires, can move forward and backwards, then also elevate the, oh, it was good. Oh, sorry. What's the mechanical problem? But it is okay. It can elevate. Yes, thank you very much. Thank you very much. It can elevate. Do what? Also, it is able to carry some load that is placed on it. It also has a steering system which helps it to change the direction. And then also, we have this driller here. They all operate in the same way, but differently. This one uses sprocket mechanism for moving. Then it has an elevating mechanism to move the driller up and down. You can press. That is the driller operating. You can feel the sound. Are you hearing? Yeah, it is operating. Then now the elevating mechanism. It can elevate that one when it is elevating towards the ground, and from when withdrawing the drilling components such as nozzles and the other shafts that are used to elevate through the ground. So these simple projects can be elevated and transformed into larger ones by using electricity, and they can operate very well as these usual machines to cater for those people who are far away from petrol stations, and we can just provide them with electrical power sources where they can recharge their machines from. Thank you very much. I beg to submit.
Hello, I'm Welcome 14884.
Walk 14058.
It's so great to be a part of this and it's so exciting.
In the dark of night, the stars light up the sky.
Okay, thank you for that, the team from Kadogo Polytechnic. So I'm going to invite our Deputy Dean, Dr. Dennis Bosa, to come and give us a short speech, and then he will call upon the Dean and the Deputy Vice Chancellor. And as that happens, the other 4 teams that have not presented, please bring your projects close so that when we call upon your team to present, you do not take up much time to set yourselves. Thank you.
Good evening, everyone. We have a new protocol. Many people are still trying to understand it, but we will understand it as time goes on. I understand we have not informed you about the change of leadership at the faculty, but you will get to know as time goes on. I want to thank the Vice Chancellor who is here with us, our Dean of the Faculty of Applied Sciences and Technology, the Director of Center for Innovation and Technology Transfer, our guests, the visiting universities, both the students and faculty of those. Yeah, it's off. Okay, I think I am loud enough. I'll continue when the microphone picks up. It is okay. I want to thank you all for coming, and we thank our judges for the work that you are doing, and the innovators. Clap for yourselves. I am called Dr. Jones Obungoloch. I am transitioning to be the outgoing Dean of the Faculty of Applied Sciences and Technology. I will invite the Dean to come and address you and invite the Vice Chancellor. I am intrigued, just a moment. I'm intrigued by some of the innovations that I have seen here. There are a lot of good ideas. I have particularly connected
Kadogo Community Polytechnic, Ernest Cook, Busitema University, Kabale, Makerere and Chambogo. And also there is Uganda Matters University. But of course I cannot forget our own Mbarara University students. So I want to thank the outgoing Dean Emeritus. However much one of our former presidents said, Entebbe warmer, but finally Dr. Jones Obongoloch had to surrender the hot seat. His term ended on 31st of March, so I'm also been in office for 7 days, and I'm feeling the heat. Indeed, Entebbe warmer. So he was the one behind this. He supported the students in terms of finances, guidance. I was his deputy in the background. So Dr. Jones, thank you so much for the work you did to see that this event happens. I want to thank Martin and your group, MUES. Thank you so much. Mr. Vice Chancellor, among the industrial partners we have, if I forget anyone, please, Martin, remind me. We have Nairo Breweries. They are here, Mr. Vice Chancellor. You needed to test something. They are here. We have Fund Boats. We have a Creative Campus. We have a Centenary Bank. A Master Student Guild. CITT. Terra Magic Brands. So with those few remarks, please join me to welcome Professor Joseph Ngonzi, who is the Deputy Vice Chancellor in terms of academic affairs, representing the Vice Chancellor, and besides being an academician, is a gyno. You are most welcome, sir.
I was trying to understand what a gyno does, but that will be during the evening tea at Dr. Bossa's home. I'm very delighted to be here. The Dean of the Faculty of Applied Science and Technology, the former Dean, Dr. John Zobongoloch, the Director of CITT, I don't know whether he's a gyno also, but Dr. Waswa, and members of the larger FAST community and our beloved students, good evening. Good evening. I was commanded to come, but even without the directive, I would have come in my own capacity as the DVC Academic Affairs. I received the invitation for this very important event more than a week ago, and so I had it on my radar. The time I was told, I made sure that I come at least 18 minutes before, and I was here. But because of the importance that I do attach to this Innovation Week, there's no way I could have run away without saying one or two things. It's exciting to hear that we have many students from different institutions across the country. That is testament to the importance of what we are gathered here for. I just want all of us to appreciate everyone who has come from beyond the must get. KIU, Soroti, Kabale, Makenke Polytechnic, Kadogo. You know, when they were showcasing their innovation, I looked a little bit behind and I saw many potential Kadogos. I bring you greetings from the substantive Vice Chancellor, Professor Pauline Chiwika. Chika Chiwika, who should have been here, but because of other pressing official engagements, she was unable to make it. But we've been discussing, and she's been trying to follow up to know what's transpiring here. As any good cadre, at the end of my interaction this evening, I'll be able to give both a verbal report and a written report to say the task that you gave me to accomplish, I've accomplished it. Please, when you're thinking of the next promotion, do not forget me. I've been at MUST for many years, or for some years. And I've gone through the ranks from being a student leader as a guild president, to being a lecturer, a head of department, a deputy dean, a dean, now DVCAA. And so it's exciting for me to see the journey through the innovation ecosystem, reaching the engagement that we are having today. You should count yourselves not just lucky, but also blessed. If you want to clap, you clap. I see you doing like this. It's important to think. It's important to innovate. An idle mind rarely brings anything of value to the community. When you task your mind to create solutions, you become a little bit indispensable. You add value to the community where you are, and that value is what the community will appreciate about you. The moment you sit down and you allow your mind to just become lazy, you become a danger to the community. And you consume resources for no good reason. It's my call to all of us seated here that as we listen to the different innovations, we'll also task ourselves to think, what can I do? Which idea or which problem can I sort out in the community? I strongly believe that innovation comes out of the desire to solve a problem. As a gynecologist, I think that's what the dean meant. But anyway, I'll go back to ask him what a gyno does. For me, I'm a gynecologist. When I look around and I want to innovate anything around women's health, I'll look at the problem list that this special species encounter. And I will task my mind and ask myself questions like, how can I be useful to their well-being? Today we are celebrating, or we are in the Engineering Innovation Week. I do believe that engineering is at the center of societal transformation. Many of the things that we delve into, that we encounter, can be sorted out by innovations that we are going to be listening to this evening. It's not enough for you just to innovate for the sake. It is also vital for you to partner with people that are going to bring your innovation to fruition. I have this other strong belief within myself that no single man or woman can ideate and bring that idea to the market, scale it up as a single person. There is need for various expertise to bring life to an idea. I asked a question to some group at town campus today, and I'm going to ask that same question to us this evening. When you look around the world, let me ask you, which is the richest place or country? Let me have answers. I'm a teacher, so you expect. Uganda is the richest place according to her. Okay, good. 4 more. DRC. Okay, richest place. DRC 2. Okay, it's like Arsenal versus Man U. So Arsenal 1 now, isn't it? Man U 2. Arsenal 2. Okay, 3 more. 3 more. Yes. US. Okay, 2 more. Finland. Okay. Sweden. Okay, bonus. Bonus. Richest place. Which one? A country with the innovative minds. Okay, good. Now, being a teacher, none of you has actually answered it the right way. The richest place in this world is called the graveyard. The graveyard. Every time you pass next to a cemetery, you should always remind yourself that you are passing close to a place that has got ideas that were buried and fulfilled, innovations that were buried and done, songs that were unwritten, degrees that were unaccomplished, some marriages that were not okay. And every time I pass there, I realize how much I owe to the world. I need to empty myself of every good idea, whether it comes to fruition or not. At least I've given it my best. As you get through the innovation process, you should always remind or remember that failure is part of the journey. And when you fail, do not remain down seeking for sympathy. People who seek for Bambi, they are true failures. People who stand out and they rise up again. Honorable, you're welcome. Let's welcome him. Yeah. Yes. Okay, so our guest of honor is already in the house. Why don't we welcome him again? So let me just summarize what I was saying. That every time you pass via a graveyard or a cemetery, you should always remember that there are trillions of dollars of ideas that were buried in that very place. You and me, having participated throughout this week, we want to empty ourselves so that we are not part of the statistic. Okay? We are not part of the story that is being told to say X and X went down in this cemetery with all the good things that the Creator had imparted into them. How many of us are ready to try and empty ourselves? Let me see your hands up. Yeah. At least you can think about any idea. The newest way to trap a rat that steals your fox. The newest way to make long-lasting construction materials. Yes. The best way, think about anything and allow your mind to wander as you generate ideas. Out of, let's say, 50 ideas, you may have maybe 2 come into fruition, and they'll be able to sort out so many things. It's my hope and prayer that the experiences of this week will not be laid to waste. When you live here, it's important for you to always remember that we were at must, for purposes of not being violent in courts. I'll say that always remind yourselves that when you are at the best university in the whole world, which is Mbara University, you had a few words inspiring you to ideate, form teams. When I come to Soroti, I'll say the same. The best university in the whole world is Soroti. But since you're here, I'll say must, for purposes of being civil. But we believe in your great potential. We believe in your ability to sort the challenges that the world is facing. We believe in your potential to be the next great innovators that history will write about, that people will be able to read about. And I pray that that is your desire. Do not die locally. Make sure that you exploit everything within you to its optimal level. I'll end it here as we've received our guest of honor. And I'll ask either Martin or the Dean or the Director of CITT to guide us on the next step in terms of proceeding forward. I welcome you to Mbara University on behalf of the Vice Chancellor. And I hope that you'll also be able to invite us to your institutions. Our students will be willing to come. As an institution, we pledge our support towards our students when they come to us. We'll try as much as we can to support them to come and engage with you since you have come. So thank you very much. Succeed we must.
Thank you so much, Professor Ngonzi, for that good speech and for those wonderful words of wisdom. At this juncture, I would love for our judges to make way to the exhibition room for the projects that were left, so that you could be able to go and so that they can pitch to you the projects in the exhibition room as we have the speeches, and by the end you will come and tell us the results. Thank you. So as our judges make their way up, at this juncture I would love to invite my superior, Engineer Martin Aroho, to come and give us a speech. Thank you.
sometimes.
and the former Minister of Science, Technology and Innovation, the Deputy Vice Chancellor representing our Vice Chancellor, the new Dean of the Faculty of Applied Sciences and Technology, the Director of Center for Innovation and Technology Transfer, our guests in their respective capacities. I wish to welcome you all for the annual MUES Innovation Week, especially for the Inter-University Creativity and Innovation Challenge. Thank you for coming. My name is Aroho Martin, a very proud old boy of Honorable Eliodat Mwesije. Yes, for 6 years in the current generation. I serve as the current president of Mbara University Engineering Society 2025-2026. For the first of its kind, Mbara University Engineering Society has organized the most successful ever Innovation Week. And within the Innovation Week, for the first of its kind, we have had the first ever Inter-University Creativity and Innovation Challenge. Within this same week, we have had the first ever debate tournament under the Faculty of Applied Sciences and Technology, and we had winners on Tuesday. Within this same week, we also had a paper contest, and this was also an inter-university where a theme was sent out to different universities, and the different students wrote according to the theme. The theme was a health-related theme, and it was merging the health sector with the engineering sector. Today, I would wish to say to the Honorable that we have also gotten the winners for the first MUES paper contest of 2026, and they shall be awarded today. Within the same week, I wish to acknowledge the different sponsors that have moved with us. Honorable Eliodat Mwesije. With us is Nile Breweries. The team from Nile Breweries, please stand up. Nile Breweries have been one of the biggest sponsors of this Innovation Week. We have Fundi Boats Uganda. The team from Fundi Boats Uganda is part of the judging panel for the final round, and they have gone to meet the projects in the exhibition room. Fundi Boats Uganda did a very great impact to the students on the first day of our Innovation Week. That was 13th April 2026. They provided
a very impactful training. Our students learned how to do simple circuit connections using Arduino boards, jumper wires, and come up with a simple circuit that can actually help them run and start up their projects for third year and fourth year. This has been a great impact to the students, where over 250 students were impacted and have actually learned these skills. I wish to congratulate those that participated in this event. Thank you for showing up, and thank you for learning, willing to learn. Yes, as Doctor said, you can clap if you're clapping. For the second time, we have organized Ambara University Engineering Quiz. And this quiz, the 4 times country champions of the Society of Petroleum Engineering Petro Bowl, they have won this trophy for 4 consecutive years. At the same time, they have showed more experience and showed their brilliance in quiz competitions. They have also won the quiz shield for the second time. And that is the Department of Petroleum and Environmental Engineering. Thank you so much for willing. Within here, we are having Creative Campus. We are live today, and people outside are watching us. Creative Campus has fully sponsored the photography and live coverage of this event. Before Honorable entered, we received Mr. Richard, who is the bank manager, Mbara branch of Centenary Bank. Let's receive him. Thank you so much, Mr. Richard, for receiving us. That day we came to your office requesting for your support, and he was able to support us. We are not happy that our students have not opened up accounts this week. We really expected the students to open up the accounts, but we believe that we shall schedule another day for Centenary Bank to come and open up accounts. We really thank you so much for supporting us. We have the Students Guild. If there is any representative from the Students Guild, please stand up. The Students Guild has also supported the MUES Innovation Week through the Right Honorable Lucky Rob Tulumba, whom we approached, and he was able to come up and provide support. With us is Center for Innovation and Technology Transfer. We have been having meals the entire week. From Monday to today, our students have enjoyed, and the sizes have grown, and the weight is increasing. And this all goes to the Center for Innovation and Technology Transfer. With being led by Dr. Waswa and Dr. Dennis, who is available, kindly stand up for recognition. CITT has always come to us whenever we go to them. Whenever I approach Dr. Medad Twinamasko's office, who is actually the biggest brain, the biggest connection I have had, Dr. Medad Twinamasko helped us invite Professor Charles Kwesiga, another senior old boy of the president of MUES. He came for our engineering dinner as our chief guest, the executive director of Uganda Industry Research Institute. Dr. Medad Twinamasiko has been the key connection in inviting the Right Honorable Elioda Tumwesije for today's annual Innovation Week. And I wish to say thank you so much, Honorable, for accepting our invitation, and thank you for loving innovation. Indeed, you deserve to be the Minister of Science, Technology and Innovation again. We do not only have these companies, we also have Terra Magica brands. One of our judges came from Terra Magica brands. They sent us a judge to come and credit the different projects on board. With all this said, I cannot go without recognizing the MUES leaders. Please, wherever you are, stand up. If you know you are a MUES leader. I, as a president, I wish to say I am very much proud of this team. Others who are still outside trying to do different activities, I am very much proud of this team. We have tirelessly worked together, and they have actually worked more than I have done to make sure that this event comes to a success. Thank you so much for your efforts, and I believe we are growing bigger together. Thank you so much. I also wish to acknowledge the presence of the different presidents of the engineering societies. Wherever you are, please stand up. The President Kavale, I'm seeing Ernest Cook. If you know we have been engaging, I know some have gone up, but if you know we've been engaging to make sure this event comes to a success, thank you so much for accepting the invitation that we sent way back in 2025 November, and you've been able to keep patient up to that day. Thank you for bringing the innovations. Our students have actually learned a lot and copied a lot. Thank you for accepting our invitation. I therefore wish to call upon every student here. An engineer is an innovator. I therefore want to say, when you don't innovate, you don't move. The world is changing. We are in a world of science. We are in a world of technology. We are in a world of innovation. Every other day, ideas come up. We are seeing different AIs being built up. Therefore, come and engage into this world. People are growing rich because of research and innovation. What are you waiting for? Dear students from the different engineering faculties and different engineering schools, let us engage more into the spirit of research and innovation. I further want to call upon the spirit of collaboration amongst the engineering students. I of one have a vision. If the medical students have an association that joins them all together as medical students in Uganda, what about engineers? What's wrong with the Uganda Engineering Students Association? Couldn't that be a good idea to build us up? I therefore call upon all engineering students and all engineering leaders. Why don't we look into this idea and also unite as engineering students across the country? If doctors are using our equipment and our buildings to unite, why can't we unite? Is that okay? Therefore, with all that said, I wish to come to a conclusion and say that together we can make it. Like the American motto says, united we stand, divided we fall. If we are to build the engineering in Uganda, we need to be united as all engineering students. With all this said, I wish to say thank you so much, and allow me at this point welcome the Deputy Director who is representing the Director of CITT, Dr. Waswa, to come and give his remarks as he welcomes the chief guest for the day. Thank you so much.
Thank you very much, Martin. Good evening, everyone. Yeah, I'm really super excited to see you again. You know, once an innovator, always an innovator. I'm an innovator, and I like seeing innovators doing a lot of amazing things. So I really take this opportunity to thank you all for being around the whole of this week. A lot of activities have been going on, the different competitions, the quiz. This is really very, very good, and it's really good to see that you can sustain this for the whole week. It's not only about coming to class and study and take lecture notes and watch YouTube videos, but also the interactions. When I saw our colleagues from Ernest and Cook, from Soloti, from Chambog, all of us coming together, it means a lot. That's the future. The ultimate aim of this association or this is to make sure that you get students from others. Society used to support this, but it used to be only most at university, only students around here. But I'm really happy to see that this has extended beyond only students from us to bringing in other students. We want to see this grow and grow, that can become really an annual gathering where we bring all engineers from all the different universities and make sure that we really have a very strong competition. So this is very, very good. Since we do not have quite a lot of time, I'll really go straight to invite the Vice Chancellor to invite our guest of honor so that he can really be able to give some some remarks. Thank you.
Thank you, Dr. William. Our guest of honor, the people seated before you, generational innovators. And we are glad to host many institutions this evening as Mbara University. We have always been a home to everyone with great ideas. Honorable Eliud Tumwesije is a person who is well known to me as an individual. We've worked together. He was my chairman in a global high school association. Not that we were the same age, but he inspires many people. He will tell you many more things, but he is a person with a lot of energy, with goodwill for everyone, and inspires many people. Dr. Eliud is now, like we've been told, the Member of Parliament. He's a former minister. He does many things. He has a lot of community impact across this country. He owns a couple of community initiatives, including health facilities. So the person who's going to be speaking to us is a friend of Mbara University and a friend of this country. How many of us have been seated for a while? So I'll ask you to stand up, and as you clap your hands, we'll be welcoming Honorable Dr. Eliud Tumwesije to speak to us this evening. Please stand up, it's healthy. So Honorable, you're very welcome. Yes.
Yeah, thanks a lot, Dr. Ngonzi, Professor. Before I say much, when I was here a few months ago, and even months, maybe they are weeks, Dr. Ngonzi was seated there and was being introduced, I think, as one of the, as the dean, but also heading a number of projects. But God was preparing something, I think, for him. So allow me to congratulate Professor Ngonzi upon elevation that position of Deputy Vice Chancellor. I congratulate you, and I do believe that God allows the system to pay for hard work. Work with him, as he says, is really been down to us and his work. And when he or Medad, even Waswa, by the way, yeah, even Waswa, if any of those calls me, I will leave whatever I'm doing and just come running. Yeah. I don't ask why, where, what. It's like somebody said that if they tell you to jump, don't ask why, how. But you ask how high. So when they called me, I said, okay, what time? And today was a big day, very, very crucial. We came from Chankwan just yesterday morning, and a lot of things that had backed up. And then today I had a big event. I also, in the church, I also do some work there. So we had a big synod. And it's only once in 4 years. So I couldn't miss that. But it also have another function of the vice president somewhere. So it was very, very tough to bring in this issue of innovation. But they tried to convince me that, you are the very first cabinet minister. You people, history, you can't change history. You can change the future. So in history, since Adam and Eve were created, I'm the first full cabinet minister of science, technology, and innovation in the Republic of Uganda. That one nobody would ever change. I'm the one who started that ministry. And and of course when there was a change, even the ministry was removed, and it's now like it's a secretariat and office of the president. It's not bad, but at least was the first cabinet minister for that area. And therefore we had a lot of challenges as we're beginning. What do we do? What is innovation? Everybody was saying innovation. How do you measure innovation? So a lot. So I was called to make a presentation here. I've not been having time. So that's what I was trying to do here. Just trying to check on my old things which I used to have. So I've learned here something new that I thought I can share with you. If you already know, there's no problem. After all, do you know how many people, how do we read the Bible several times? The same verses. But how many have converted? And given their lives to Jesus? There are not very many, but every time we go through the same, so we don't get tired. So in case you have heard this, just for about 3 minutes, no problem, don't get tired. But of course, yeah, so we have what we call the Organization for Economic Cooperation and Development, or OECD. It's an intergovernment economic platform with 36 member countries, top rich countries. It was founded in 1961 to stimulate economic progress and world trade. So it defined what we call innovation. And it says, innovation, it defines innovation as the implementation of a new or significantly improved product, good or service, or process, or a new marketing method, or a new organizational method in business practices, workplace organization, external relations. Innovation involves deliberate application of information, imagination, and initiative in deriving greater or differentiated value from resources, and includes all processes for generation of new ideas and subsequent translation into useful products. So I hope these people, the judges who have gone to judge, are using this definition to decide what is the best pitch. The scholarly community, these are the professors. The other one was a definition by OECD. But the scholars like Professor Ngonzi, Professor Wasu, and others advance 3 categories of innovation. 1 is product, 2 process, and 3 business model innovation. Additionally, the use of new management practices and organizational structures, the development and retention of skilled personnel, and new ways of securing financial resources and managing interface with government and other external agencies, and also forms of innovation. So So for us in government, it's also an innovation. You approach the donors, there's a lot. So if you look at product innovation, like I think what you're involved in now, mainly product. Everybody is showing a new product, pitching like a new way of solving a problem, isn't it? I used to come and attend a lot of hackathons here at Mbara University. And even at Makerere, I haven't been able to make it to Bustema. Yeah, but I work with a lot of people from Bustema. And Soroti, I haven't visited. But because I was on the Social Services Committee of Parliament, I was in Parliament for 20 years. And most of these universities really started when I used to serve on those committees. So product innovation, it has three forms. One, the development of purely new product. Purely new. Sit there. Like I always imagine, I always see the AI models. Somebody comes up with like a car. They say, let me make a car for like Professor Waswa. I said, okay. I think Waswa likes this height. What? So, but sorry to use your name, but because it's your name that I know, But different models. You come up with a completely new product. That's one innovation of product innovation. Two, it can be an improvement of the performance of an existing product. Actually, many of the people, I don't know about your pitches, but most of the people actually look at how do you improve an existing product. How do you bring the two products and then you make one? Then three, you can also just be a new feature. So you can improve the performance of an existing product. That's innovation. You can have a new product. Or you can just create a new feature to an existing product, such as including a navigation system in a vehicle. Drivers of product innovation are typically technological advancements, changes in customer requirements. In other words, what makes people think of product innovation? One, technological advancements, changing customer requirements, or an outdated product design. Product innovation is visible to the end user and often results into greater demand for a product. Then we have what we call process innovation, which includes changes in the equipment and technology used in manufacturing, like improvement in tooling and techniques, improvements in software used in product design, development, supply chain and delivery systems, as well as the methods used for accounting and customer service. The need to optimize production costs is the foundation of process innovation. One of the most famous and groundbreaking examples of process innovation is the world's first moving assembly line by Henry Ford. Very first moving assembly line. This process innovation by Ford not only simplified vehicle assembly, but also shortened the time necessary to produce a single vehicle from 12 hours to 90 minutes. Of course, I think now with the Elon Musk and Tesla, maybe they can even produce a vehicle. Maybe like, less than an hour. It's done. But I say in Uganda, we can take weeks. I used to supervise Chira. I would go to the railway industry and see. It take long, even months to come out with a bus. But I think now it has improved. So I don't know here in the pitching which was done today whether there are a lot of process innovations. I didn't get time to study that. I think it must have been in a product innovation. Then finally, there is also a business model innovation. This one I think is not visible. Business model. So you can have product innovation. You can have process innovation. You can also have a business model innovation. This one basically focuses on changes in the way products get to the market. This includes penetration of new markets. I think for you people, you need most of this because you are making new products. There already been a lot of products in the market. So how do you penetrate? So you have to innovate a business model. It includes penetration of new markets, new supply sources or distribution methods, and new industries. Business model innovation is radical, risky, and transformative. And you can think of online stores like Jumia. You can think of knocked down contract assembly systems, mobile money examples. All these are business model innovation. That's one segment I wanted just to highlight. The types of innovation. So that when you're talking about innovation, you know there are systems on this. Then you also, how do you measure innovation? How do you say Uganda is more innovative? Like we have been saying, I think in the world, and all of you can test it. You can see South Korea, Israel. These are some of the most innovative countries. You can see the Israel has done. You know, like having like all these wars. There are just 6 million people. Yeah, but what they are disrupting, they are causing all this. I wouldn't say mayhem. Causing all these challenges which are there. 6 million people. It's because of innovation. I was talking to somebody recently, like for us it takes like, we use about 8 billion to construct a road, a tarmac road, 1 kilometer. Between 3 and 6 and 8 billion. Now Israelis have come out with a technology which can even use less than 1 billion. And where you don't even have to drain swamps. Just they are saying that you do and mix some chemicals and you put the tarmac there. That's innovation. And the best measure, how successful a country would be is measured by how innovative it is. If you see what has been happening on Ukraine, that Ukraine and Russia war, they have shown really high rates of innovation. Now because they have no soldiers, can you imagine? And this is very, very interesting. Yet now, like between US and Russia and Ukraine, I don't know who will even win this war. Now they are moving away from using human beings. So they are putting robots. They are fighting using robots. So I was imagining now if you send the robots and then they meet robots, when will the end? Yeah? But conditions are making them very, innovate. So next thing now, like Ukraine has been invited to go to Saudi Arabia to help them with stopping those missiles. But then globally, we use 2 indices, and there could be a third one, but I know 2 indices. One is what we call Global Innovation Index. And you can go and Google these things. Global Innovation Index. And then we have also Bloomberg. I think you have seen Bloomberg TV. Bloomberg is very, very good in terms of business. Bloomberg Innovation Index. The Global Innovation Index aims to capture a multidimensional facets, of innovation and provide the tools that can assist in tailoring policies to promote long-term output growth, improved productivity, and job growth. The Global Innovation Index provides a key tool and rich database of detailed metrics for economies. So I because of the time I can't go through that, but you'll go and Google what are the metrics, what do they take to check, and then you can also see where Uganda is in terms of Global Innovation Index. So they rank all these countries, and you see how they have been moving across a number of years. And then you see how you can advise us in the government on how to improve. On the other hand, the Bloomberg Innovation Index is more brutal. It does not, eventually the final list usually has very, very few countries. The Bloomberg Innovation Index ranking process begins with more than 200 countries. Then they assess using different measuring yardsticks. And each country is scored from 0 to 100 based on 7 equally weighted categories. These ones, what they use to measure countries. 1, what they call R&D intensity. 2, manufacturing value added. 3, productivity. high technology density. These are things you can always check on Google. Tertiary efficiency, researcher concentration, and patent activity. Like countries, how many patents? You can ask, like in Uganda, how many patents were registered? And I think someone has taken you through that, the issue of patents this week. Must have discussed it. Then what's because no, these people, they need to give them that information. If they have not, next time. Because they must immediately be thinking of how to protect whatever you have done. And you have to protect it. It's like the African, it's called Aripo, based in Zimbabwe. You register, and then you get a patent. The patent means someone that use your method, your product, will have to pay you. It's called patent. You have patent protection. Then there is also what I think is called WIPO, an international one based in Geneva. So for you who are innovating, you must immediately see how to protect whatever you have come out with. So this Bloomberg Innovation Index would see how many in your account, how many patents have been registered. The researchers, how many researchers do you have as a proportion of the population? Over all researchers, they don't look like that. They look at these people with PhDs. How many PhDs do you have per population? Yeah. And they rank you on that. So, and very many things I don't have to go through. And then nations which don't have complete data, those are eliminated. Like Uganda, in most cases, they used to be eliminated. Yeah, but now we have improved. So as a country in Uganda, we need to transform. So you can always go and check what they call Bloomberg, like Bloomberg TV Innovation Index, and see how you are staying, how they measure countries. That for you as an innovator, you know how you will benefit. Then you also check on Global Innovation Index. Uganda needs to transform with a major focus on being creative and innovation-driven country, which calls for heightened action, and among others, increased funding for innovations and rapidly establishing the innovation infrastructure. Before I left that ministry, we had started what we call National Research Innovation Program, under which would award money for people with very good ideas, would put out calls, and I think that's what is being done to support you as innovators. Now the rest I can always maybe put on a website, or if you have your system, I can always put all this for you. There are some interesting things which I also want to discuss. I used to go to Makerere when I was Minister of Science and Technology. Go there, find these engineers especially. I used to go to SEDAT. Sometimes IT, but find somebody with very, very good ideas like what has been put on today. Very brilliant, very exciting, very, very good. This young man. Now, after graduation, after about 2 months, you see him taking you in a border. There's nothing as hurting as that one. This gentleman, when he was at the pitch, he was talking really very, very good things. But when he finishes the university, reality sets in. He has to look for accommodation that night. The hostel, they have just a guy from the hostel. The other things which he had in the pitch, he can't even connect to the where I had even stored them. He goes onto the street, has to look for border. It is hurting. And I spend a lot of my time really trying to see what we can do. So all over the world, it's not only Uganda. That whole spectrum from idea generation. Then you come out with some theory. Then you have some prototype. Then you test. Yeah, to eventually getting a viable business. That whole R&D spectrum is a nightmare. And scholars have come out with 2 interesting areas or regions of high risk requiring financial intervention. And the government, that's what we have to push. One is called Valley of Death. You have heard about this. And the Daunian Sea of Abakombi. So you'll find that you have somebody has generated, has done basic research, has come out with new ideas, now needs capital to develop these ideas into an innovation or an invention. So there's many things die from idea actually coming out with an invention or an innovation. So they die in what we call no capital valley of death. Then after that, somebody has a very good idea, applied research, innovation, now comes out with an innovation, an invention. So the struggle of invention becoming an innovation and becoming a viable business, then you find people cannot be able to go through that. Instead, the innovation dies in what you call the Darwinian Sea of Abercrombie of technical and entrepreneurial risks and bureaucracy. So the person has an invention, they even mentioned there is an invention here, an innovation, somebody is even walking with his head high. But now moving from there, a viable business. So now as a Minister of Science, I did two things. One, of course, was to establish the National Research and Innovation Framework and fund support from the President, support generation of ideas into inventions. Now from inventions and innovations into viable businesses, we developed some things like incubators. And I think CIT, Professor Waswa, CITT, and the other people in other universities did think about this. An incubator. I think you people you have even more languages like accelerator and all that. But the whole essence is, here is a young man at university. He has used his ideas, he has worked as a team, they have now come out with this good product. But as they move out, they have no money, they can't even hire a building. So how do they take, what will be next? That's why people have come out with those incubators. And for us, we had set up one in the industrial area. We call it the Technology Business Incubator. In Namanve, it's actually next to Uganda Industrial Research Institute. It was also under my ministry. This end, we have what we call Technology Business Incubator for bananas. But there are very many. I think universities can also have their own incubator. So that by the time somebody finishes the university, he already comes out with like a business, a company is already formed. So incubators help one, there is equipment to help you improving your product. Two, there are these so-called the venture capitalists. They can easily come and then they know where to find. And therefore, you get space where you can improve your product, you can do marketing, get feedback. There will be joint, common warehouses. There are places where venture capitalists can come. So I think universities can think of that. So we had that in Alisa's government, in Namanve. And then we have also established one, like if you're going back to Kampala, you people have come from Stema. Before you reach the Antonde on the left, you see new buildings which have come. Yeah. In Rebitate is called Rebitate after the some milk factory gate. On the left before you reach Sang. New buildings. I mean, I wanted to call it National Institute of Technopreneurship. I think the name has since changed. Called Technopreneurship. Why? There are many technocrats who also want to become business people, but they are not trained in business. Two, there are also people who are trained, like now in your engineering courses, Maybe there are some products, some machines you are missing. Like I went to some companies in China. You can go to a factory. You see maybe like 2 human beings around. But you see machines moving, you can see a car coming and lifting something here. It has no driver. It takes it somewhere, exactly in the same spot you want it. It's using what they call the Internet of Things. I'm forgetting some of these things. Yeah. So, at Rugabitete, we had wanted to bring all these products. That like an engineer. If you have been trained where you don't have exposure to modern tools of production, industrial, but also in engineering, we had 7 clusters. But of course, even as many universities and other NGOs have also come up with incubators with such facilities. So I encourage you to, after the pitch today or after pitching, when you go through, try to look out for all those opportunities that are with government in order for your innovation not to die in the Devonian Sea of Abercrombie, or your idea dying in what they call valley. Yes. We want to see many businesses coming out of your work. I actually, when I was designing this national research and innovation program, I went to Malaysia. I went and visited the Minister of Science of Malaysia. I said, how have you been doing this? And he told me that, for us, we get you. We give you money as government. We handhold you until your business is listed on the stock exchange, either in Malaysia or UK. And afterwards, then when you are listed on the stock exchange and people buy shares, then we recoup our money back to government and support us. I think that's the model we should take. But I want to encourage you to continue to process your innovations and inventions that you have, and to know that there are chances in the government, chances in UN agencies to help you reach your goal. Also, in Rwebitete, they are going to issue a call. They issue calls now. So they have a call, I think. When I came, I was inquiring. I said I'm going to meet engineers and other people at the university. What should I tell them? Then there will be calls in the next 1 month. Like if you have completed engineering, or you have a product, even if you have not completed, you can apply. We have, of course now things have improved. But in the past, like Uganda, we didn't have many 3D printers. These computerized numerical control machines, CNCs. How many of you have seen the lab for printed circuit board? PCB lab. Can you put up your hand? PCB lab. Wow. Then what were you going to do? All these electronics that I see you have been learning. Maybe you have it here in my hand. So like every electronic gadget has what they call a motherboard. With all those small wires. Like a control system for the electronic. So all these used to be made from abroad. But here at Rwebitete, we put them there. Even Yuri labs help you. Because whatever tool you are using, you need that cupboard, that motherboard to control things. Yeah, we put them. You can crap actually without even that goes told you if you want crap, you crap. That's what I heard. That yeah. Because when we started, we didn't know these things. I just traveled to UK, I traveled to USA, to Russia. I went to MIT, this Massachusetts Institute of Technology. That's why I got this name, NIT. I saw really their best things. For us, our machines were using were like in Katway. That's why they needed this. So you have to know those things of additive manufacturing. Instead of cutting, you add using those printers. We didn't have them. Get their simple tools. So I do believe that our universities, we would have all those gadgets that if you have come out with a product, you can shape it to what you need. Then if you're an engineer, get an accountant, get or some entrepreneur, whatever, get people on your team. Before you leave university, you should have registered the company. I don't know the USB has come here this week. Yeah. So many have registered companies. Put up your hands. Yeah. Only one bank. And how much does it require? I think they are just few bottles of beer. Eh? Hey, is it 98,000 to register a business? It's less than 100,000. And like if the universities call them, maybe they might not charge you for about reserving a name. I mean, if I check the name is not there, why should I pay for reserving? But anyway, you can also pay for reserving your name so that nobody steals it. So that by the time you, I think you must have been using Teams when you are pitching. Now those teams should register companies next week. Yeah. Register your company. It doesn't necessarily matter because you're at university. That's when you register the company to refuse it. No. Register the company. Then start working on looking for capital. If you're a lady, look for Grow. Grow is there. Yeah. Even recently, there is money in Bank of Uganda called Small Business Fund. They started under COVID. 10%. The money is there. People never came to take the money. Yeah. Then there is, I think, UN some fund in United Nations. Of course, UDB will require many big things. I don't know whether you can qualify also for yoga. You can say you're engineer, but the money is retro for yoga. Eh? Yeah. There's money for the youth and the yoga. These are used. If you go and get like 30 million, because the yoga has no limit, I see. So, the point I'm trying to make is that don't waste time. Now that you have been here, you have pitched whether your thing has succeeded or not. Go ahead. Come at least some company. Open a bank account. You can say you can first eating for some few weeks, some eating certain things for some few days. You keep some money. What is happening now? And this is the last point. Like recently, the Secretary of Treasury was saying Uganda's growth rate, I think we are heading to about 7-8%. But you find like Norway or Sweden, GDP growth will not be more than 1%. Why? Because they have reached their maximum. But here, you can imagine, you look at the homes in your home, in your village. Many things they lack. So many things they lack. Even sometimes getting matchbox is the real problem. Let alone other things. So now these Ugandans now we are about 45 million, 46. By 2050, we are going to be assuming people continue producing the way they are producing. We are going to be 105.7 million. Then come to East Africa, because now we have increased, we have added Congo and other countries. But before Congo, and I think Somalia, we are like going to be 442 million by 2050. Now Africa has about 1.3 million people now. By 2050, if you count 4 people on this planet, 4 people, one will be an African. Right now, Nigeria, despite Boko Haram disturbing them, for every child born in Europe, Europe including Russia, East and West and South of Europe, there are 10 Nigerians being born. For everyone European, there are 10 Nigerians. China has tried to make sure people can produce. People have refused. They have made on one child policy. So basically, it's Africa and India maybe, and some of the other Arab countries. By 2100, 2100, and this I got from a professor in Manchester, there will be mainly blacks on this planet and self-replicating robots. In some countries, like in Europe, a person would go with his wife. They won't have sex from Monday to Monday, including Sunday, from January to January, including Christmas morning. No baby. Fertility issues. But here in Africa, Uganda, yeah, you might find someone has come from Mustema to come and do a pitch in Barara. Then he says, I'm going to town, maybe to buy something to help with the pitch. And when he reaches like at this time, they would be doing something. Yeah? Then we used to say that as he was beeping, you know, like you want to beep. You are beeping somebody, so he calls you back. Then instead he picks you immediately. So that's what happens. These people, they have gone for beeping, and very soon then the lady will say, my mask has disappeared. I didn't see my mask. I don't know you. What are you talking about? What are you saying? You found me in the beach in Barada. Don't you remember? We met in the beach and then we went somewhere. No, I don't know you. Yeah, you need switches off the phone. That's what happens to Africa. Africa, they just produce because of what? Evolution. What am I trying to say? Is that whatever you have come out as a product, even if you have not been the best, don't continue to develop it. Because Africa, where you are located, and Uganda, which is geopolitically well located, you are going to have a growing market of nearly every consumer product, every infrastructure development. Huge. Because the population is going to be large. We are going to be, is it 2.5 billion? Africa will be like 1.3. By 2050, we shall be about 2.5 billion. The whole world will be 9.8 billion. So all this market now, and we're opening up as a government, we have put continental free trade area. You can do your product here, and you are seated here, you sell it on your website to someone in Nigeria, or someone in Algeria, or someone in South Africa, and you don't pay tax. You only pay delivery. So don't relax. The market of East Africa is huge. Don't just look at Uganda as a market for your product. No. Innovation. Start with the products which you have at home, which your father has been working on. How can you improve on them? If he's been getting from milk, yogurt, for you aim at getting whey protein from there. Yeah. If you're selling bananas which are raw, you sell biscuits made out of banana flour. You know? For those from Busoga who are near rare earth minerals, start thinking of how you are going to participate in that business. If you are in MUES and you have gold, start thinking of how do you make gold rings. But even if you did social work, it does not prevent you from innovating and having a business in gold. Yeah. So open your minds for the continental free trade area, free market, for the growing population. Look for money, grow your products. There's money available in the Ugandan market. Low interest money. Struggle. Don't say, that's money, nobody can get it. You try. And you'll be victors. With that, I wish to stop here and wish you all the best in your careers. I wish you to be rich, to be okay. And all these things will be very, very well made. And they would go very, very well if you accept God. And if you are, hey, these people who went with ATM, is it called ATMs? ATMs, these guys who went between the whatever, between the moon, beyond the moon, I think. They went in some area where you could not even, they were just on their own. But when they said when they were there, and they looked at this cabinet us, where Trump is disorganizing everybody. Yeah? And I mean, many people disorganize each other. Let me not only point out Trump. Yeah? And they looked at really the planet us, and they looked at what they said really the creation of God. It was wonderful. Actually, many of them came when they were saved. Yeah. And those are astronauts. Then how about for you who are pitching here? So it doesn't hurt. Whatever religion you are, you follow your religion, and God will help you get the capital, get what you require, protect yourselves. I mentioned it somewhere, it was misquoted. Yeah, protect yourselves, don't simply go far. Yeah, because many of you are very good. We don't want you to die of AIDS, or die of these other funny things. If you can avoid alcohol, even if you're a scientist, avoid it. Because those are things which destroy you people. Alcohol, drugs, and sex. Once you manage those, manage your innovation, you'll be prosperous. May God bless you for God and my country.
Another round of applause to our chief guest. Thank you so much, Honorable, for such a very motivational and encouraging speech to the young innovators. So, as I had said, we have one of our biggest sponsors, and when our guests came in, we had to rush into some speeches, and it is surely would be something very interesting before we go in for the awarding ceremony, which is the next session after here. I would wish to call upon the systems maintenance manager of Nile Breweries to come and give a very few remarks, and then our chief guest will award. The results are ready. Please just wait. Is that okay? Just wait. And our chief guest is also a little patient. Please, you come. It's okay.
Thank you so much, guest of honor, and all the participants who have come to this Innovation Week. Myself, I'm called James Ongaria. My role is Manufacturing Systems Manager. So I look after the automation aspect of Nile Breweries in Barara plant. So a lot has been said. I wish I also had time. I would have said a lot. But in brief, as you look at our banner here, we say we dream big. So it means we always want to be best in class. So in manufacturing, we always want to be the best. And you can only be the best sustainably if you keep innovating, so that the customers are happy with your product all the time, your product is appealing all the time, and you are also attracting the best talent within the country to manage your processes. So we are ready to be partners with you in the automation space, around manufacturing, around agriculture. Happy that this university also has the Faculty of Agriculture. We also have a lot of things we do. You know, to make the beer, we use cereals, grains, which are all over our country. So we also want a lot of innovation in terms of improving the quality of those cereals, so that the productivity or the extract out of those cereals that we use is top notch. So with those few words, I thank all of you for participating, and we'll always be available and willing to join you in case you invite us. Thank you so much.
Thank you so much. Nile Breweries is one of the most receptive companies you can ever approach. I feared to go, but when I reached, I even had lunch. Yes. You remember Mr. Perplex took me. I reached there at around, he told me, be here at 12:30. Me, I reached at 1. When I reached at 1, it was lunchtime. So he said, could you come on with us to go for lunch? And if you go to Nile Breweries, their lunch every day. We did the same meal today. So ladies and gentlemen, the annual Innovation Week always has competitions, starting all the way from the day one. We had debates, we had quizzes, we had paper contests, and we had the Inter-University Creativity and Innovation Challenge. Ladies and gentlemen, every competition had a winner. Is that okay? But behind every winner, there was a sponsor. So allow me to first award our special sponsors. Please come this side. To first award our special sponsors. We awarded some on the engineering dinner. So, when I received power, the first partner we received, I'm going to request our dean, the director, CITT, the deputy vice chancellor, and our chief guest of today to kindly stand up in honor as we come to receive and award these sponsors that have been there for us. Some we awarded during the engineering dinner. They started sponsoring us. So we are going to start with our very own, the youngest sponsor on board. I don't know if they are here. Mbarara Sports Hub. Are they here? Unfortunately, they are not. Okay. Dear, we also had Bethany Engineering Limited. It is a civil engineering company. They were not able to make it here, but we still appreciate them. So, we now go outside. This event is covered live. I'm going to welcome my vice president and my deputy speaker, plus the speaker. Please come and we hand over this certificate of appreciation in recognition for the exceptional support to Mbarara University Engineering Society activities 2025-2026. The contribution has been invaluable and we are looking forward to more collaboration. Creative Campus. Mr. Sankala, I see you. Oh, yes. We're having a representative from Creative Campus. Please kindly come and our cameraman is ready. Okay, so that is Creative Campus. Thank you so much for supporting Mbarara University Engineering Society. We are very grateful for your support. I know students are waiting for their awards. They are also coming. Now, ladies and gentlemen, the most impactful of all the companies that have actually trained our students with skills. Fundibots. Yes. He's in shock. Yeah, this is how Mbarara University Engineering Society does. We appreciate. We are very grateful. Mr. Octavius, I don't know why Mr. Yes, thank you so much, Fundibots. When I approached the manager, he told me, we don't even need to debate. He called Mr. Polycarp, he called Mr. Henry. Please accept what they have requested. Thank you so much for supporting us. Ladies and gentlemen, Mbarara University Engineering Society has an account. And it is on this account where all these companies have been sending money. It is on this same account where when the students pay subscription, it goes to that account. Ladies and gentlemen, I wish to welcome Mr. Richard, Centenary Bank Uganda. He supported us. He's the bank manager of Mbara branch. My students are actually requesting to shake hands with you. You can come like this. Yes, yes. Dear cameraman, these are memories. Yes. Take this pic with me. Exactly. You see, these are importances of coming up and being leaders. Showcase, show up. Next semester, I want to see new leaders. Thank you so much for supporting Mbara University Engineering Society. And ladies and gentlemen, we have faculties, and in this faculty, we have different departments. One of the key and most supportive departments, this department set the Innovation Week quiz competitions, questions. One of the lecturers in that department. This department fully attended the engineering dinner. All the lecturers were there, a full table. I wish to call upon the head of department, accompanied by the lecturer of the civil engineering department. Yes. Yes. The students standing here, 3 of them are civil engineering students, I inclusive. The deputy speaker and the speaker are all civil engineering students. Plus the emeritus president, Katongole Adam, a civil engineering student. Thank you so much, please. Yes, Mr. Pathias. Cameraman, please don't miss this moment. It's a very memorable moment. Hey, you, don't miss it, don't miss it. Yes. Thank you, Madam Josephine. Madam Josephine has been so much supportive in this Innovation Week. Thank you so much. Yes. Ladies and gentlemen, this was not, we are done with our sponsors, the people that were behind all the awards. Now, we always have quiz competitions. For the second time, we are having the second time we are having our quiz shield appear. And ladies and gentlemen, allow me welcome the second time winners and champions. They have defended this quiz shield. Every other time it is won, it is taken to the head of department's office. And when I was picking it from there, Mr. Fortunate Ogene told me, it's okay, you can borrow it, but you will bring it back. And indeed, he meant his words. I wish to welcome the team that won the Petro Bowl competitions 2026 at Chambogo. And again, the team that won the annual MUES quiz competition 2026, Petroleum and Environmental Engineering. These people have given golden medals. It is a quiz we believe it's worth being given a medal. Therefore, our chief guest is going to dress each one of them. So our chief guest is going to dress each one of them as they bring the shield very near. Thank you so much for showing that competence. They couldn't wait. They had actually taken this shield, but they said no. Mr. Elioda must dress us. So the dream has come true. Cameraman. Exactly. That is Engineer Dante. Every time they used to answer questions, there was a certain player for him that was answering every logic and reasoning question, and he's actually putting on the medal right now. Please don't go back. Don't go. You've forgotten something. Jordan, please bring the shield. Let's clap for them as they. These are the second time quiz champions. So ladies and gentlemen, this shield was introduced when I was the Research and Innovation Secretary, when Katongole Adam was my president. I am glad that as now as the president, I am awarding again, but next time civil engineering, okay. Painfully, but okay. Petroleum engineering, I wish to say, they are the second time quiz champions 2026. Please, the Research and Innovation Secretary can take this through the hands of each guest here. Yes, as you take a peek, it should go up to the chief guest who will present it to the team that won this shield. And to the coming MUES regime, you have a challenge of bringing up the debate shield. I have stopped there. Thank you so much for winning that. Thank you so much. Please take a pic with the chief guest, with Dr. Joseph Ngonzi. He's in charge of academic affairs. Indeed, you're in his department shining. How I wish you had brought back the SPE trophy. So ladies and gentlemen, we also had for the first time ever the MUES debate competitions. Allow me at this point, before I welcome them, let me talk about them. The team that is coming is a team of year 1 students. This is their second semester in campus. The team that is coming reached the semi-final of the quiz competition and made a tie. They made a tie with the quiz champions of 2025. It was a tough quiz tournament. They actually merely won the second game, the tiebreaker, but they couldn't make it because they were still young. However, they said no. The same team actually made it to the final of the first ever debate tournament. And I would wish to welcome biomedical engineering students who managed to be the winners and the champions of the first ever debate tournament organized by Mbara University Engineering Society. Dear Honorable, these are year 1 students. All these are year 1 students. None of them is in year 2. So these are the year 1 students that were able to take the trophy, and we wish to congratulate them. Dear faculty courses at Chumuro, you have a challenge. By the time these guys finish year 4, I don't know if you will be having trophies for debate. But be caution, take caution and be careful. This team is really showing energy. Entirely year 1. What an impression. That is Maria. Yes, that one is Noeline. I need that peak. Yes. Wow. 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 Next is Mark. Michael. Yes, Michael. Followed by a very funny student, full of fun, William. They did not just dress the medals, but the Vice President wishes to take it. They also received an accolade. How I wish the next coming cabinet, I will say it again, you owe me a debate shield. Yes. Thank you so much. Please take a picture with the chief guest. Thank you for showing that kind of competition. You deserve it. Ladies and gentlemen, before I continue, now we are on the competitions of today. Hello. Hi. Are we ready? We are going to start with the paper contest, and I would wish, I feel too low to read this. I would wish someone bigger. Our judge, a representative from the judges, to kindly tell us the winners. The winners of the paper contest tournament.
Thank you so much, the president of MUES, our chief guest, our Honorable Dr. Riodat Mwesji, the DVCAA, the Dean, Faculty of FAST, and the students available today. Good evening, everyone. How are you feeling? Are you ready? DJ, some music. Are you ready? Okay. All right. Second runners up. Drum rolls. Drum rolls. The second runners up is HRV monitor. Anes Cook, yeah. DJ, more sound, more sound. Before we read the first runners up.
Free music on
Drum rolls for the first runners up. Are you ready? Are you sure you're ready? All right. The first runners up. A data-driven framework for addressing structural inequalities in Uganda's public health systems. Congratulations. All right. Are you ready for the winner? Are you ready for the winner? DJ. DJ. Hey, DJ, don't disappoint me. Hey, you're looking for the song. Okay, drum rolls for the winner. And the winner is... Are you ready? Okay. Assessment of the impact of iron ore mining harvested rainwater. Kabale University. So this was for the paper contest, okay? But the winners for the innovations are also going to come up, yeah? But I would like to say for the people that have not won, at least you've learned, right? You've learned something from this Innovation Week. And I would like to thank my fellow judges because I did not do this alone. So clap for the judges that gave us these scores. Thank you.
Ladies and gentlemen, yes, the judges. So today that we had the finals, on the finals we strictly had company judges. None of them is affiliated to a university. So there was no bias. Therefore, allow me introduce the judges.
All right. I am affiliated to this university. So my name is Martin Mukama. I work for the Center of Innovations and Technology Transfer here at MUST as the Senior Prototyping and Technology Development Officer.
Thank you. My name is Asimwe Lydia, also affiliated to the university. I am the project manager for the MUST IUC UCOBS project, and on this judging team, I was gender balancing, but then also from a management and business background.
Thank you so much. I am called Polycarp Mulepu Masaba. I work with Fundi Robotics Limited as a technical associate. Thank you so much.
Yes, good evening. My name is Octavius Nwazirwe. I work with Fundi Robotics Limited as a technical associate. I'm an innovator.
Good evening to you all. My name is Alex Nwagawa. I work with Terra Magic Brands as an operations associate, and I also work with Progressive Health Partnership as an operations manager.
Okay. So these are the people that awarded us. These people said they're affiliated to MUST. I didn't see them in classes. I don't see them in classes. They had innovation projects that are situated within MUST. Yes. So, I now wish to welcome DJ. This team has worked tirelessly to make sure today comes to a success. If you know, please, Team MUES, kindly come in front with the awards for today. DJ, give them the welcoming song. No, please make sure you don't. Hey, please Please, please make sure you don't disclose anything. DJ, DJ, DJ. What is written behind those boards? But this is the MUES team. Kindly. This team has worked tirelessly. So, our dear chief guest, the winner of today goes away with 1.5 Ugandan shillings. 1.5 million Ugandan shillings. Ladies and gentlemen, the runners-up of today goes away with 1 million Ugandan shillings. And the first runners-up of today goes away with 500 Ugandan shillings. 500,000, please. So, dear engineers in the place, I don't know. Allow me to allow you. To allow me, my vice president is telling me. Allow me to call upon the second runners-up of today, DJ. Hey DJ, are you getting music from Modondo? So allow me, please, if you know you're holding the one of 500,000, come this side. Just peep into it. Either you know they are smart. Yes. Allow me to allow you welcome the water flow leakage detection pipeline. Mara University of Science and Technology. Please, DJ as they come. Please pass here before you get started.
Baby, right now, originally no be China, oh no be China. From today, I want the day where you day. Kilo be, you want the follow my sexy.
Yes, these are the second runners up from Barra University of Science and Technology. Team Mastoy. Mastoy. Now, they are wondering. It was one team per university on the finals. So Mast is out. Yes? So if you know, yes, please, hand over the check. Katomba Adam. Society, thank you so much for the spirit of research and innovation. DJ from mutundo.com. Okay, please, let's all stand up. The award is getting bigger. Let's all stand up. Yes, let's all stand up. First runners up, please. A check of 1 million. Are we ready? On the count of 3, 2, 1. Team Mindset! From Soroti University. Are you ready? Are you? Yes, Team Mindset, come forward. Girl called Mata, them one Mombasa. Please come here. Allow me. So, allow me. Drum roads. How do they call them? Drum roads. Yes, okay, please. Yes. Allow me to call upon the low-cost, effective, self-disinfecting centrifuge from University. Here, I remember on 6th March, we had a biomedical engineering inter-university tournament, and the same university won 500,000 from here. Indeed, they are very good in innovation. They have really come to take our money. Please, the core team members, the medals are going to only the core team. MUES is dressing the team. Thank you for showing such a very good competition. Such an interesting moment. Have such the same event maybe in Soroti University. You ready? And must will come for the money. Yes. Allow me hand over the microphone to our chief guest to give the closing remarks before he leaves.
Okay. The Deputy Vice Chancellor, the heads of department, Mbarara University Engineering Society, our judges, and all of you participants. I wish to take this opportunity to thank all of you. Want to thank the winners, the first runners up, the second runners up, and all of you have participated. Keep up the struggle. Don't relax. Improve your products and processes and business models. Form companies. Attract funding. Improve and work towards a viable business. To earn you money, earn our country money, and bring inclusive prosperity for all. May God bless you and bless your universities and bless Uganda. Thank you.
Please, MUES executive and cabinet members, please come forward. MUES executive members, we have a group picture with the chief guest. Please, let's try to fit in all. Yes. Side. We shall have